to come in and sit down, but the talks are starting at 1:30. So for another 25 minutes, we won't be beginning, but feel free to sit down. Hello. And welcome to Django Under the Hood. I am super excited to be here. We have got 300 awesome people in this room. Congratulations to all of you for making it here. I am going to just introduce the conference and do a bunch of important housekeeping things to start with, and then we shall crack on hopefully fairly soon with the exciting program. To start with, if anybody has not yet found the Wi-Fi, it is under the hood, and the password is under der Motorkap. I apologize for my Dutch accent. There are posters with this around if you can't work out how to spell Dutch. Once you've found the internet, which I understand is a little flaky, but we're working on it, please use the hashtag DUTH on Twitter. And when you're talking about it, also use our official conference emoji, which is, of course, the sparkles. For those people who are unfortunate enough to not be able to be here, we do have a live stream of the conference for the first time this year, as provided by the wonderful John at the top. This is available on YouTube, or alternatively, you can go to djangounderthehood.com/live, and that will be much easier to find. I would like to thank now all of these wonderful people. These are your organizing team. You will probably have encountered several of them already. We are identifiable by our red lanyards through the conference. If you need anything, please talk to one of them. Probably not me. I don't really know what's going on. We have a photography policy, so those of us with red lanyards are organizers. You will hopefully be aware of this from registration. If you have a blue lanyard, that means that you're okay to have people take photographs of you. However, if you see someone with a yellow lanyard, please refrain from taking and publishing photos of that person, as they don't wish to have that done. Similarly, we have a code of conduct in place. This is available on the website at djangounderthehood.com/COC. If you have any problems with anything, no matter how minor or otherwise you think they might be, please do talk to us. We have these 5 wonderful people. There are posters around with some phone numbers on, and the details are on the website as well. If you have something you wish to report, please do report it, and we will deal with it appropriately. We will probably also be publishing a document after the conference with the details of what has happened for full exposure. We've got sprints on Saturday and Sunday. Can I have a quick show of hands so we know how much food we need to buy? Who's planning on coming? Basically everyone. Great! I'm very happy about that. We're going to do some great things. We've got a whole extra day of sprints this year compared to the previous years, so good stuff. On the desk outside is a feedback box. This is your opportunity to tell us all of the wonderful things that we're doing and all of the things that we're doing not wonderfully. Based on last year's feedback, we're going to just do a little segment here to introduce some of the Django team and the wider Django community. One of the things we do with this conference is that all of the members of the Django team are invited to come to the conference. And we try to make sure that this is the one time in the year that we all get together to talk about the future of Django and where we're going. It has been a previous criticism that this group of people tend to not spend very much time with anybody else and just talk to each other all the time. So we're actively trying this year to be outward looking and to have as many conversations with as many of you as we can. So the first thing we'll do is I'll get everybody up to sort of introduce themselves, say hi, say who they are, say what they do and what they're interested in and what they'd like to talk to you about. So if I can invite any members of the Django core team in the audience to come up onto the stage for the moment. Gonna need a bigger stage.
What's the weight limit on the stage?
Hopefully not too low. So we're just going to go through everybody very quickly, and I'll just like everyone to introduce who are you, what's your name, what do you know about, what are you interested to talk to people about. So we're going to start with the people who've been here the longest.
I'm only the second longest. Adrian's the old man. Hi, I'm Jacob Kaplan-Moss. I have been involved in Django since the beginning. Adrian hired me to come work with him at the Lawrence Journal World about a year before Django was open sourced. I can talk broadly about almost everything that's gone on in Django, but not deeply about almost any of it, because I tend not to be deeply involved these days. I work for the US government. I'd love to talk to people about that. We're trying to make the government do IT better, which is fascinating and awesome. And I'd love to meet people, especially who work for other governments. I think that would be so cool. So if any of you do tech for government or other civic institutions, I would love to talk to you.
Hey everybody, I'm Adrian Holvati. I've been doing Django stuff since the beginning, and I live here in Amsterdam. So I'd love to talk to you about any historical stuff if you have questions on why things are bad. Looking forward, I'm really interested in offline stuff. So if you've done any work with offline service workers, that kind of thing, that's something that I would like to add as a first-class thing in Django, or maybe a second-class thing. And also, separately, would love to talk about music and being an expat and having a 5-year-old kid.
Start down this end. You just pass it down.
Hi, you probably know me as Funky Bob, and that's the name on the card, so that'll do. Yeah, I know lots about lots of parts of Django except the ORM. I'm too scared of that bit. I've been working on it for 10 years now, I think, and helping out on the IRC channel most of that time. Yeah, happy to talk about just about anything.
Hi, I'm Tobias McNulty. Been using Django for about 9 years now. I'm the newest member to the core team, but probably my largest contribution was the contribute.messages framework. I don't even remember what version of Django that arrived in, but many, many years ago. A lot of other people went into that, but that's probably I sort of championed it through and may know a little bit about that, but these days I'm more focused on training and helping new people get into using and developing Django. And I guess I should mention Cactus Group too, which is a company where I work and help found in North Carolina. We do all Django development. So it's been a big part of what we do, and Django is something I love through and through and would love to talk to many of you about.
Hi, I'm Daniele Procida. I have been working with Django for a few years. I work with Divio. I'm a Django CMS developer. I'm probably easily the least useful programmer on the core team and possibly in this entire room, but it doesn't matter. It means you can come and talk to me about anything and you need not feel bad about starting from the beginning, because that's where we all start from. So come and talk to me about that or about anything else you do with Django. I'll be very happy to talk to you. Thanks.
I'm James Bennett, possibly better known as Ubernostrum. I started using Django pretty soon after it was released. Then Jacob made the mistake of hiring me to work with him at the Journal World. And then I made the mistake of volunteering to help with packaging up the releases and somehow ended up doing that for a few years. And then we paid Tim to do it, and he does a much better job. Really interested in security, also in sort of the future of Django as what was the phrase, standard library of the web. Which is a thing that I care about quite a lot. I'll plug my company, Clover. We're trying to make the U.S. health system not be awful. It's up there with making government do IT better. So if you want to talk about that, come find me. I have business cards.
Hi, I'm Andrew. I'm on stage after this, so I'll keep it very short. But if you want to come talk to me about networking, about channels, or about systems architecture, I'm happy to talk about that and many other things. And the rest of it you'll hear in a little bit. So.
I'm Tim Graham. I'm contracted full-time by the Django Software Foundation to basically shepherd Django development. So I review most of the pull requests. and shepherd the releases.
I'm Carl Meyer. Been using Django since about 2007, I think. And I like to talk about testing, clean architecture. These days I think a lot about scaling code quality to large development teams. So I'd love to talk about that or anything else, really.
Hi, I'm Josh. I work for Kogan.com, an online retailer, a little bit of a plug. I work with the ORM mostly, and more recently the Expressions API. So if you want to talk about the ORM, if Funky Bob doesn't feel comfortable doing that, I do. So I'm one of the few people here that probably can speak about the ORM these days.
Hey, I'm Florian. I'm known as Apollo 13 on IRC. I'm using Django since like 10 years and try to help out on the IRC channels. If you have any really, really weird bugs that are bugging you since ages and you just want another set of eyes, I'll happily help out there, and also if there's anything security or infrastructure related.
Hi, I'm Russell Keith McGee, Freakboy3742. I've been... Not 31. I've been a member of the core team for coming up on 12 years now. So I'm probably the third oldest representative in the core team here. So I've been around. I was DSF president until the end of last year. Frank took over at the start of this year. My interests now are mostly in getting Python and Django running on other interesting platforms. So Python on mobile, Python on set-top boxes, Python on your phone, on your watch. And there's a booth over in the far corner that is populated with bees. So come and have a chat if you're interested. Come and talk about the bees. I'm also interested in bees and Australian animals that may or may not kill you. So come and talk to me about that if you want.
Hi, I'm Ola, and if you want to talk about diversity and Django girls, then come to talk to me, if you can find me, and I'm not very busy running the conference. Also, if you want to talk about ORM, or if you are very bored with Django and you want to talk about Elixir, which is so awesome, then come and find me. And also, if you're interested maybe to learn something about running Django at Google App Engine, you can grab me. I'm not an expert, but I know something. So, yeah, that's me.
I am Simon Charette, known as Charette on RC and GitHub. I'm currently working for Zapier. And yeah, so I'm interested in working with the ORM, migrations and testing infrastructure in Django.
Hello, I'm Aymeric Augustin in French. I'm part of, let's say, the third wave of Django core developers. So I've been a core developer for about 5 years. I have touched many parts of Django. I have strong opinions about everything, but you can make me, you can easily make me change my mind. And things I've written 3 years ago in the ticket tracker may not be still true today. So willing to discuss and reconsider just about everything.
Hi, I'm Idan, and I'm giving Daniele a run for his money when it comes to the most useless core developer. It's true, like with numbers, true. So I'm a designer developer hybrid, and I don't really do a lot of Django anymore. Don't throw tomatoes at me. I do a lot of JavaScript. I work at Heroku. I'm interested in data visualization and working with data and how to make that less painful. So talk with me if that's your thing.
Hi, I'm Loic. You might know me as Loic84 on IRC. I work mostly with forms and the ORM, and tomorrow I will be talking about validation in Django. And I work in the humanitarian sector, WFP.
Hi, I'm Marcus H. on IRC. I've took over pretty much Andrew's migration part after the 1.7 release. Care about migrations, security, deployment. There's a bunch of stuff I'm happy to talk about.
Hi, I'm Karen. I used to contribute a whole lot more to Django many years ago in the 1.0, one time frame, and then I got a full-time job working with Django, and I live in hope that I will one day find time to contribute more again. I always hope. I'm willing to talk about anything. I really enjoy helping people learn things. And outside of work and Django, I do cat rescue. So if you're interested in talking cats, I can do that too.
Hi, I'm Tomek. I care mostly about the community and making Django a nice place for everyone. So here am I helping to organize this conference along with Ola and other people. So, and Mark and Anya. Well, anyway, that's what I care mostly about. So if you want to talk about inclusive events and community, hey, I'm here.
Hi, I'm Frank Wiles. I'm the current DSF president, and so if you want to talk about anything about the foundation or with fundraising or anything like that, I also specialize in like performance and scalability. So if you're interested in making things go fast or businessy consulting kind of stuff, come talk to me.
Hi, I'm Michael Manfrey. I'm pretty much known for doing the database backend stuff as one of the people that uses SQL Server and runs Django on Windows. So if you want to talk to me about any of that stuff, cool. I also kind of know the ORM pretty well, so that's me.
Hi, I'm Tom Christie. I work full-time on Django REST Framework. Come and talk to me about anything to do with web APIs.
And I guess to complete the set, hi, I'm Mark Tamlin. My biggest contribution to Django is Contrib Postgres. I have a strong interest in the ORM. I'm currently mostly eyeing up forms and maybe the admin, and I have some really crazy, stupid, big ideas. So if you want to know how ridiculous those are, you can come and talk to me about those. Thank you very much, everyone. On Saturday, we will be putting on a set of dinners, or well, I say we, really, that lot of people you just saw will be putting on a set of dinners in the middle of the sprints on Saturday. If you go to djangounderthehood.com/dinners, you'll be able to sign up for one of these. The idea is that we get 2 of these people that we've just been talking about, or some of the organizers of the conference, and a number of other people, and we book a restaurant together, and we go and talk about stuff. So there's a set of restaurants and people and topics, or starting topics, realistically. If you're interested in doing that, go and sign up for these dinners, and hopefully we will see a lot of you there. I'm going to crack through this a little bit because we're running slightly late. But I would particularly, we have a number of things that we really need, people who we really need to thank. I would start off with the Dutch Django Foundation, and in particular Yuri Becker, who acts as the treasurer for the foundation. He has handled all of the financial concerns for this conference with great speed and efficiency, which has been extremely helpful. A conference like this cannot be put on without sponsorship. I won't tell you what our budget is because I can't remember off the top of my head, but it's lots, so we say. And in particular, I'd like to thank these companies. Our largest sponsor for this conference is a company called Sonoma. They are one of the largest Dutch media publishing companies. They have a booth outside. If you would like to talk about that and you have an interest in them, I'm sure they will be delighted to see you. I also believe they have free hats. There are also so many people here that they don't even fit on one slide. All of these wonderful companies, who I'm not going to read out now, have contributed to the financial backing of this conference. We are extremely grateful for everything that all of them do, and to all of these ones as well. Tomorrow, we will be having a social evening at 8:30 p.m. at a place where I'm not going to pretend to pronounce. This event has been made possible by the sponsorship of Sentry, who hopefully you will all be familiar with. There are some t-shirts for them outside. They do tracking of errors. If you haven't investigated them, they're great. I use them. And finally, I would like to thank Potato and all of the various people who have put this stage installation and so on together. It is a ludicrous amount of work, and and makes the conference really rather special. So thank you very much to everyone involved with that at Potato. Okay, so that's pretty much me done now when it comes to introductions. So we can finally crack on with some talks. Questions. For those of you who have not been to Django Under the Hood before, firstly, hi, welcome, nice to see you. Secondly, you will notice that our talk slots are very long and very vague in their abstracts. We choose a bunch of topics, we choose a bunch of speakers, and we invite them to come and talk about this stuff, and we give them a lot of time to go really deep. We don't cover many topics. We've got 9 talks over the course of the conference, vastly fewer than, say, a DjangoCon Europe, but we try to make sure that we can go as far into those talks as possible. If you start to feel like you're getting a little bit lost or the talk is getting hard, that's fine. You will not be the only person in the room who is feeling that way. I get lost quite regularly. In fact, I make them all tell me their talks beforehand so I have some hope of understanding what they're talking about. We don't do questions in the traditional format where you would come up to a microphone and ask questions. There will be a Slack channel in the main Slack for each of the talks, which we will open at the beginning of each talk. If you wish to ask a question, please post that question in the Slack channel. If you like some of the other questions that are there, please add little thumbs up icons under each question so I can see which questions are popular. At the end of the talk, we will have a sort of conversation. I like to think of it as like chat show style, but that's probably me getting carried away, with the speaker, with me, and I will present those questions to the speaker and we'll have a conversation about them. Any questions which cannot be asked because we run out of time, the speakers will hopefully be able to go into the Slack channel, catch up with those questions and respond there. We're going to leave those channels open for the rest of the conference and the sprints afterwards. So anything exciting that comes up from that particular talk, we use a place to continue to go to talk there, to go to talk about it, to go and talk about sprint ideas that you want to do for it, and so on. I have one request. During the talk and for a sensible period of time afterwards, please do not answer anybody else's question. These are questions for the speakers, not an open platform for you to show off how much you know. I would also remind everybody that a question has a question mark at the end and is not a statement. It needs to actually be a question. If anybody does not have access to Slack or hasn't worked out how to get there, I mean, we have internet issues, but we'll do our best. If you don't have access to that, if you send an email to hello@djangounderthehood.com, then you will get an invite back promptly. Hopefully most people have been on the Slack already. It's been really great. So, one of my responsibilities with this conference is to establish the schedule of talks, as work out who's going to talk about what. So some months ago, I started asking people, what would you like to see talks on at Django Under the Hood? This seemed like a really great idea. I'd get loads of good ideas, and I could compile a long list, and then we could cut it down and choose which talks we want to have. Unfortunately, 95% of people all said the same thing. And what they said was, channels, please. So, didn't really have any options. Your wish is our command. So I am delighted to welcome back Andrew Godwin to Django Under the Hood. He's probably best known for his long involvement with the migrations framework, both through South many years ago and now Django Migrations. If you want to know more about the internals of migrations, you can find a video from 2 years ago where Andrew first spoke at Django Under the Hood. But migrations are kind of solved now, for some definition of solved. They're solved enough that Andrew got bored and wanted to do something else. Now, Andrew doesn't like easy problems, so we decided to go for, let's just make Django async as a small problem to look at. So to explain roughly how this was possible, and something about channels, please welcome Andrew Godwin.
Thank you very much, Mark. So as Mark sort of alluded to there, there is a lot to cover. This is not how it's meant to look as well. Let's go there. Oh, Windows, hold on. There we go. Lovely. So there's a lot to cover, and I'm going to try and give you a reasonable idea of both the rough scale of the problem and then dive deep into the Django-specific part of it. I could probably speak for a whole conference on this topic, but you don't want that, trust me. So let's get diving right in. First of all, I'm Andrew Godwin. As I didn't say earlier, I am a Django core developer. I work at Eventbrite, where I'm one of the senior software engineers there. I used to complain about migrations a lot, but apparently they're solved now, so it's all, no, it's... Marcus, thankfully, is doing a lot of the heavy lifting on that stuff now, so I got a bit more free to look at channels. And really, a lot of you, I presume, want to know how channels work. So I have one answer for you. It's magic. Thank you. It's been a great... No. It's not magic. It may seem like it at first. But basically, I'm going to try and outline to you what the problem is, or sort of the context that this sits in, because for some of you, it'll be familiar. For others, it won't be a familiar problem. And then go through both my solution and thought process, which some people find interesting, and then look at the actual code that came out of that process and some of the edge cases and problems we have. But first of all, what is the problem? Well, the web is changing. Back in 2005, when Django was started, the web was a simpler, happier place. Their websites were static HTML with a couple of interactive bits. JavaScript was sort of a thing you used for like making the status bar animate or having snow on the page at Christmas. It wasn't very exciting. But since then, things have changed. We have rich web applications. We have data binding. We have WebSockets. And WebSockets was really the thing that drove me to this in the first place. About 4 years ago, I started getting involved with WebSocket stuff, initially as sort of a web games thing, but also just because I like things that are overly complicated and pointless. But since then, it's developed into a sort of more interesting thing. And the first thing I want to tell you all about is that, unlike common conception, channels is not just WebSockets. It's one of many things in the modern web, and all these things exist today, and there's more coming, that exist that are not just request response. Django and WSGI and a lot of Python web stuff is built around this request response, synchronous worker pool kind of architecture. And all of these things, like long polling, for example, you cannot do with that, because if you have that architecture and you have a long poll that holds open for, say, 30 seconds, then all of your worker threads are just idle for 30 seconds doing nothing. And the same goes for things like server-sent events, where you hold open things and send multi-part chunks back. So we have all these issues, and we have Django that is very capable at doing normal web pages and has done that very well, but isn't really suited in its current form to these kinds of challenges. And this is down to a couple of key things. The first is very obvious. Python, at least for a long time, was synchronous. It's only been in the last couple of years with the newer Python 3 versions that asynchronous sort of handling and code and the way we can do that libraries have come to being. And even then, Django is still a synchronous framework. The problem with async libraries in the way that they are best written is that you need an entirely separate API for synchronous and asynchronous libraries. You basically need a whole second standard library. And going back to the thing we heard earlier about Django being the standard library for the web, like, we would have to rewrite most of the important parts of Django to be asynchronous. And so rewriting Django, unless you can find me a team of 10 amazing developers in a couple of years, is probably not going to happen in the near future. And there's more on top of that too. So while asynchronous code is lovely, I would heavily advise you to only write asynchronous code where you have to. I can write it. I try not to whenever I can, because it's easy to screw up. It's easy to get horrible mistakes and problems. Deadlocks or live locks abound. Synchronous code is easy to think about, easy to reason about. And on top of this, if you think about the true meaning of what it means to be an asynchronous framework or system, often that means like, oh, inside a single process. So say, look at something like G-event for Python. It can do lots of green threads in a single process. But once you've got a WebSocket server that's in a single process, what happens when you make it two processes or two servers? How do you extend beyond that machine boundary? And so I was seeing this much more as, how do we take this problem of there are these individual units of work and spread them across not just multiple threads or processes, but across a network of machines, because that's how the modern websites work. We have clusters, we have data centers full of stuff. And finally, important things for sanity, it has to be a proven design pattern. In my younger, more naive years, loved inventing brand new, exciting things that didn't work very well. I'm now a bit older and a bit wiser, and things that have been proven to work and have research and have like write-ups on how to do them is very important. Like, you won't get very far without building on the shoulders of the giants that came before you. And so that's a very important thing for me because I don't want to have to do all the years and years of research and testing to prove if something works reasonably well. And finally, I had to be able to explain it because it's no good if it's an amazing system, it's elegant, and one person in the world understands it. And that's the same for your code. Code written in this system should be easy to reason about, easy to think about, easy to sort of like just understand what's going on. So given all these constraints and many more that I'll sort of touch on over the rest of the talk, what fits those constraints? Like this is the thing I sat down a couple of years ago and I had been researching on and off for a few years before that. Like how can we solve this within Django? And one of the big things here is the idea of loose coupling. Now Django, I think used to promote on the front page the idea that Django is like this fan of loose coupling. It's a design pattern of the way things are done. And what it means in a couple of ways, well the first thing is it means not being too tied to WebSockets. As I said earlier, they're not the only problem. There's more of a general problem here with the web not being this purely synchronous flow anymore. And also shouldn't be too tied to Django. Django has been, for a long time in the past, this sort of standalone monolith in the Python community. And it's important to have a solution that's a bit more open, a bit more welcoming, and that we can have our friends in the rest of Python help us with, because there are many people in the rest of Python who are way better than me at networking, and they have their own projects. So having them included is a massive help. And the second part of loose coupling is the idea of the fact that you can swap out components, that there is a well-defined minimal interface that you can take and you can program against, and then if you want to change what's on either side of it, you're free to. And that's kind of a key part of what Django is, right? Like the template system now, you can use Django templates, but if you want to, you can just pop Ginger in there. It's not too difficult. You've got to rewrite the templates, but it's an option we give you. And Django has this philosophy of you build on Django to start with, and as you grow, pieces fall away, and you can replace them with your own piece, with your own thing. But at any given point, it's a slow, gradual process. Like Django is modular. You can pick and choose what you want. So let's look at a proven design pattern first. There's not many options for talking between machines. There's been a lot of research into it. And the one I have had a lot of positive experience with and generally prefer is the message bus. So the message bus is the idea where you have a single centralized bus. It could be a server, it could be a cluster, it could even just be a file. But it's a single place you point every server or every process to. In particular, what you don't do is that none of the processes know where the other ones are. All they talk to is the bus. And you put something on the bus with an address. You say, hey, send this to, and you give a name. And then something else can listen and say, hey, I want things for the name. And it delivers them across. This is a heavily proven thing in research. It has some issues, but it's always trade-offs with large system design. You have to trust me on that in some sense. And so that's kind of the basis why I sort of started off. And like, there's some good solutions there. And then the question is, well, okay, you have a message bus. Clearly, you send messages over it, but what do the messages look like? Like, how are you encoding things? If we're going to do WebSockets, what does that mean? And secondly, as well, like you have a bus, but how do you talk to it? What does that interface look like? So, how do you send it? And this is the basis of what channels is. Channels is rooted in a specification called ASGI, which stands for the Asynchronous Server Gateway Interface. Definitely not based on WSGI, definitely not the case. And what this is a specification for both of those things, both how you talk to the message bus and how you send things over it. So this is the 5 functions of how you talk to that message bus. You can send and receive, and in particular, the send is always non-blocking, and the receive is blocking or polling, you get to choose. And so that's how you sort of do your basic communication. And then the second part is a group system. And this is the key difficult part of the problem, because doing messages between different machines is not too difficult. You can do it pretty easily. But having a broadcast system that works across a network is a difficult problem. And so that's baked into the very core of channels, is part of this specification and part of the thing that gets implemented is the idea of a group. You have a group, you can add and remove channels from that group, and then you can send to the group, and all the channels in the group get the message. And this is a very simple basic broadcast system, but it's enough of that minimal interface that you can build on top of it. And then, what are the messages? Well, the actual semantics, the thing inside them, is defined in a little bit, but like in terms of a format, what's the restriction? Is it binary? Is it text? Is it just numbers? Is it Morse code? And what I ended up with was It is a JSON compatible, as in it only uses the types that JSON can represent, dictionary-based format, as in the top level is always a Python dictionary, text encoded message onto the channel. And in the API that you have in ASGI, all you do is send and receive dictionaries with these basic types in them. The encoding, the serialization is all done for you by the layer underneath. And that pluggable layer, the thing underneath those 5 functions, is one of the swappable components. Oh, apparently I'm a very excitable speaker, and that pushed the force of this away. That's fine. We okay? Yes, excellent. And so that, that's part of the specification that you can swap out. Like if you want to encode things as JSON, you can. If you want to use message pack, you can do that as well. The key thing, as long as you stick to this interface and provide dictionaries out to Python, it doesn't care. And so let's dig in a bit more with an example, because talking in abstract is very difficult with this kind of thing. I prefer using very concrete examples for things so you actually have an idea of what's going on. And so let's look at WebSockets. If you're not familiar, they are a stateful socket that basically, it starts off as a HTTP connection, and then you send a header saying, I actually wanted to upgrade to WebSocket, and then if it supports it, the server sends back, okay, and then it's sort of, the nice text part vanishes, it turns into binary, and then frames start happening. But essentially, you've got a couple of different parts of the life cycle. You have a connection phase, and in the connection phase, the client talks to the server, says, I'd like to open a socket, my origin is this, I'm coming from this frame, and then the server gets to go either, no, we're denying the connection based on security or overbearing, sort of overloading policies, or it gets to say, yes, I accept this, and it sends a handshake back and then negotiate and open. Once you've opened, you can send and receive in either direction. You can send or receive whenever you like, as many times as you like. You can just wait, you can open a socket and then leave it open for a day and then send one thing and close it. That's perfectly acceptable. You can open a socket and then just receive things down it and then close it. There's no particular ordering there at all. And then finally, at the end of a life of a socket, it disconnects. And there is a thing in the spec that says, when you disconnect, there is a code, a bit like the HTTP error code, that says why. It's like code 1005 means it closed unexpectedly, for example. And so this is kind of the framework of what WebSockets is as a protocol. And the job is, how do we take this protocol as an abstract concept and map it into what channels is? And this kind of is part of the design of channels. What you do is, because you have this messaging system, you have this bus, what we're doing is devolving protocols into a series of events. And what happens is, for each one of those events, you send a message onto the message bus under a certain named channel. So, for example, here are those 3. When the connection happens, a message gets sent onto WebSocket.connect. When a message comes in from the client, it gets under WebSocket.receive. And when somebody disconnects, it goes into WebSocket.disconnect. And what's happening is, on one end of that message bus, there is a server sitting there terminating the sockets. It's a separate process, and it's handling that sort of all the handshaking, all the decoding for you, and just turning it into these nice messages onto the bus. And then your job as a Django program is to receive those messages and act upon them. But of course, to act upon them, you need to do things the other way. Like you see here, the arrows go both ways on the slide. And so what you have to do is you have to send back to that socket on a channel as well. And so not only do you send from the client to the server on these connection, receive, disconnection channels, you also send back from the server to the client on a special channel. Now, you may notice there is a different kind of formatting on this channel, and there's a good reason for that. So if we look at the idea of how this bus might be laid out in a bigger system, let's say here's one. So we have 2 of these separate servers, and both of these servers, imagine like Unicorn or Nginx, like a separate process that terminates WebSockets. The socket goes into there, it gets terminated, decoded, parsed, and then all that comes out of that is events onto the message bus. Separately, you have a couple of Django worker processes listening on that bus for channels they're configured to work on, and then when they get a message, they go, oh, wake up, take the message, run the code that you've written for them, send things back, and go back again. Now, when someone connects or sends a message in, any of these Django processes can handle it. They all have the same code in theory. And so what we can say is, well, we'll just send on to the connection channel, and whoever's ready can pick it up and go with it. It's great. That's how general worker pool handling works. It's fantastic. But when you send something back, you can't just say, oh, send this back, either server can handle it, because the socket is only on one of those servers. The client has a TCP connection to just one of those two processes. So you have to route back that socket to the particular process that has it. And that's kind of the distinction we have inside channels. You have these top set, which are general, world-routable, anyone can handle them channels. And when you have an exclamation mark, it means, no, this channel has a specific process that's trying to look out for it and receive it, and exactly that process can handle it. And that's in there so that the message bus implementation can actually handle them in different ways for more optimal performance. It can understand that, oh, if I see this character, I can actually do a different kind of routing for it. And all this comes down to, if I tell you there's a message bus, the first question you should ask is, well, what are the trade-offs? Because any distributed system has a set of trade-offs. If somebody tells you their system is perfect, they are lying to you. They should not do this to you at all. And so there are a series of trade-offs. The first one is, how does delivery fail? So say I send a message and the system is in a non-perfect state. What happens to my message? You have two options. Either the message doesn't deliver, or the message delivers more than once. And the architecture, you can imagine, there's different ways. Like, not delivering is pretty easy. It just drops in the network somewhere. But you can have systems too. Kafka is a good example of this, where in a failure state, you'll get multiple duplicates of the message. That's their failure state. You get at least one. Channels is an at most once system, where you get the message at most once. So that means either you get it or it drops. This is generally a lot easier to reason about, and often how you design websites in the first place. It is also first in, first out. That means if you send a message onto a channel, and then another message onto the channel, the first one there gets handled first. This is a queue versus stack distinction you may, if you've done computer science, you may have heard of already. You then have things like back pressure. So a channel has a capacity. So by default, WebSocket.connect has a capacity of 100. So if 100 people try and connect and the server is behind, the 101st connection event tries to get added in and send goes, whoa, the channel is full. And then what that means is it tells the thing that's handling the socket, oh, well, the backend system is full and overloaded. I should drop this connection and send back an error code saying, oh, 503 or 501, the system isn't working very well. Please come and try again later. There's a few other things to highlight as well. Because of the way it's designed, it's not sticky. When you have all these different workers listening on a channel, any one of them could get that particular message at a time, whoever's ready and gets it first. And so if you have a socket that opens and it goes, oh, connect, receive, 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 disconnect, it might be a series of events you have on the channel, that could go to 5 different servers. And in fact, it could go to different servers and happen at the same time. You could have connect and then receive, receive that gets handled by 2 different servers simultaneously and in parallel with each other. And this is hard to reason about. So that's kind of an annoying thing of this architecture. And as I said, it's a trade-off. If you want, you can have both of these things. You can have guaranteed ordering, you can have serial processing, and you'll have a massive speed drop as a result. But we'll come to some of those in a second. So let's look at what they actually look like, these messages. Well, here's an example receive message. When you have an open WebSocket, someone sends you a frame. Now, WebSockets are a framed protocol. That means that you get distinct sets of data, so like as a chunk, and they can be either text or they can be bytes, basically binary. So imagine someone sends in a text frame. So it comes into this server that's on the edge of the network, has the socket tied to it. That server goes, okay, decodes the binary frame into reasons, and then goes, okay, well, that's a text frame. So it sends this message. The first part you can see here is that, yes, it is a text frame. There is a text part of this message that says text, hello world. That's what we got sent. And the second the last 2 parts of this are the metadata. And they tell the server what this means, because in this system I showed you before, it's an entirely shared nothing system. This is great for scaling because you can just launch more of them. But what it means is that none of the workers keep any state or know about each other. And so your only way of understanding that these things are part of the same socket is to have something in there that says, oh no, these all come from the same socket. And what we do is we reuse that channel that you send things back to it on as that identifier. So the reply channel here is both the way of sending things back to the socket. So you can say, oh, I'll take that and send something back to the person. But also your way of saying, oh, this is the same socket as that one I saw 3 seconds ago that had the same reply channel. And you can use this as a key in another data store, say a cache or a database, to tie those things together. Much like you would with a cookie, for example, in Django. And finally, you have a path. And this comes in, as we'll see in the routing later in the talk. But when you have in Django code that handles these messages, there's kind of a URL-like structure in there where you say, oh, well, for things under this path do this, and things on this path do this. Because they can only work on things in the message, what we do is we bundle the path in with the message when it comes through. We don't bundle like the headers or anything else, just the path. And this was a sort of later addition onto the thing, but it's very useful, as you'll see later. And this is not just WebSocket. So as I said before, you can take a protocol, you can decompose it into events, and you can say, well, what does this mean? How do we approach this in this event-driven system? Like, it's an event-driven system where all you can do is write code that happens against things that happen in the protocol. And so we have a full spec with proper musts and shoulds and everything for HTTP and for WebSocket. So you saw there part of the WebSocket spec. I'll just go forward here. This is an example HTTP connection in this case. So for the HTTP, you get a request channel, and then you send back on a response channel. It's very simple, but it still fits the same model. And so see here, you get well, here's our reply channel to send our response back on, but familiar things like the method and the path and the query string are all here. And in fact, this is just a sort of superset of what WSGI provides, so it's sort of intercompatible as well. But it's not just web stuff. You can also apply this to other protocols. We have rough drafts and people looking at and interested in working on both IRC and Slack as messaging protocols. So the idea being that you could write a chatbot where, things appear on the chat.receive channel, and you can just write code that acts on received messages and just send them out in the same framework. There's an email rough draft I've been working on where you could write things that handle incoming email in the same framework, where you go, okay, well, we have a message on the email receive channel, let's look at it, it has these headers, we can respond in the same way. You could do, in theory, any protocol. Two I have done in the past and recommend you never do. Minecraft, which is, you have to do special Java-only serialization in Python. I have a whole library for that if you're interested. And screen scraping mainframe terminals over serial connections. Both possible, don't do them. But in general, there's more, we're trying to expand the number of sort of specs just as a health measure to see if we can do them, but try and get a few more things than just these top two in there. And going back to this list again, so I highlighted these two earlier, and they are problematic because WebSockets are an ordered set of frames that you expect it to handle basically one after the other. And so it's not a great user experience if I tell you, oh, it's fine, just make your code so it works perfectly run one in parallel on 5 machines at once and handles ordering all the wrong... No. As I said at the beginning, writing asynchronous code is hard. And so what we've done is as part of the spec where actually those received messages have a fourth key, they have an order key, and that key tells you, oh, this was message number 5. And the second part of it is that what we can do is we can use that order number and then we can use the reply channel with a caching store and just have the system tell you, and it's built into channels, as you'll see, oh, enforce ordering on this channel. And what it'll do is it'll trade off some speed. Obviously, you lose some speed to synchronization and the collaboration algorithm, but you do get your things executed perfectly serially in order. So if you want it, you can do that trade-off yourself with a single decorator we have for you and just have it work. And the second thing that is, in fact, a very recent development in channels is that what we've done is rather than before, where you'd connect to the server, it would negotiate and then send a connect message, and then it would just always accept and then just start sending receive messages. What we've changed now is that it does a connect message and then it holds the socket in the handshaking phase, sends to your application and says, hey, do you want to accept this or reject this? And once you've sent back accept or reject, then it continues to either open the socket or close it. And what this does is give you implicit ordering, and the connect always comes before your first receive. And that's the most common problem people had. So it's kind of hard to understand all this, and as I said, I need a few hours. So let's go through some of the components of this system. So I've been talking about the server that terminates and the stuff in channels. So this is the 5 packages that currently make up the channels project. There is channels, the eponymous package that is the Django integration that ties ASGI, the thing I've been telling you about, into a nice Django-ish framework, and we'll get to that in a second. But there's also the other parts of what makes ASGI run. The Django part is just one part of the whole system. There's also the central part, the message bus. Like, there has to be a piece of code that plugs in and does all this delivery for you. And the idea is it's a bit like DB API 2 in Python, like the sort of common database interface where there's a series of pluggable things for whatever you feel like doing. So there is a Redis backend, which uses Redis for delivery. There is an IPC one, which uses shared memory segments if you want to be on one machine. There is an in-memory one for testing. And we actually have some people looking at writing one on RabbitMQ as well now as well. So the idea is you to choose from this set of options based on your deployment, your experience. Maybe you have some of these deployed already. But if you whatever you want and fits your situation, you can have that particular delivery mechanism. And if you want, it's not a very long spec. If you have a person on your team who really likes asynchronous code, let them write one that fits your scheme or fits your custom networking protocol, and that works as well. And then finally, on the other end of all of this is the mystical server that turns WebSockets into events, and that is called Daphne. Daphne is basically, I took Twisted and Autobahn, two excellent pieces of code, put some hot glue in the middle, and then just tacked on ASGR on the back of them. All it does, it uses the Twisted Web standard HTTP handling library, Autobahn, which is a very well-proven WebSocket library, and then just takes all the things where you plug in, like where you handle those, and just puts in send to the channel there instead. And whenever it gets received from channel, it just then responds onto the socket. And that server is the thing that handles taking these connections and turning them into events on the channel for you. If you want, you can just run Daphne. It will handle HTTP and WebSockets on the same socket. It will auto-negotiate none of this path prefixing stuff you may have seen. But if you want, you can also just run your standard Nginx or gUnicorn on one side and then just send WebSockets to Daphne if you'd like as well. So I mentioned previously, channels is the Django-ish part. So let's go into some deep detail on that Django-ish part, because that's kind of what you're here for. So crucially, I want to highlight that what is here has been a lot of revisions. It takes a lot of tries to get a nice API. It's still not fully there yet, although it's most of the way there now. And so what is here is based on a lot of thought and like what feels Django-ish. There's no specification for what is Django-ish. There's not a big list the core team has of like, oh, well, it means this, 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 and this, stamp of approval. That's not how it works. It's more sort of a nuanced thing of like, well, what feels good for the users, what matches expectations, what's not surprising, what's boring. Boring is good in Django world. And so the first thing is, well, everything every Django developer does is write views. We're all written views, they're great. So what if the fundamental unit of work in channels looked basically like a view? That was my sort of guiding principle of this project. So consumers are the things that you write against these channels, and they look like views. Here is the code. What happens is you write a callable that takes a single thing, so it's not a request, it's a message, but it's very similar. You do some stuff with the thing you got given, and then you can send responses back. There's a couple of differences. So first of all, you can send responses anywhere in the consumer. It's not a return like it is with a view. You get that reply channel back in the message. So as you can see here, you have both message.reply channel at send, in which case what this does is this is tied to a channel. It gets the message. It then says OK. It sends the message text OK on the reply channel of the message. Then it uses the group system. Now, this is just a very concise example, but say in the connect handler, we said, oh, when someone connects, here's a consumer that says add them to this group. And when someone receives a message, here's a consumer that says send to this group. Ta-da, you've got a chat application. Like those two things give you broadcast text chat between all the clients connected. Or you can just do ORM things. You can do whatever you like. It's a normal Django process. The normal Django database cleaning applies. If you want, you can wrap transactions around in there. It's just basically like a view, but a bit more complicated. And that kind of ties in also with the way the routing works. Now, I like the Django URL system. It has its problems, but I've grown to know and love it, maybe a little bit of Stockholm syndrome over the past 10 years. And so keeping it to look like that is kind of important. And so what you have is you have this list, sound familiar, of regex-based matches of what to do. So imagine this example. You have basically a list of, well, this channel, in this case, WebSocket.receive, and if the path is chat socket, send to this function. You can include, like in URLs, and even like in the URLs file, if you include with a regex path, then that bit's stripped from the previous one, from the next one down. So you can say, oh, this prefix goes to this file, and then just not have the prefix in the file at all. And the nice thing is as well, you can have class-based consumers in the same way you can have class-based views. And as well as having everything sort of more generic, and there's a set of generic class-based consumers as well, those consumers can in fact emit their own routes. Because in particular, the one change you see here from URLs is that URLs don't have a channel. In URLs, everything is on the HTTP request channel. And so this has a little extra information. And so what we can do is those class-based consumers can tell the URL file, oh no, I need these 3 channels. And the root class decorator takes that information from the class and uses it for you. So there's no duplication of content in this file. And so as I said before, it is a shared nothing system. These things could happen on different machines in different parts of the world even if you have a weird message bus set up. And so how do you share state? How do I have a thing where I can send a message over the socket to set my username and then have another message come through and then that remembers my name and comes back again? So you could use a database. Databases are great. But you can also use sessions. And we all love sessions. They're a good temporary storage. And there are 2 kinds of sessions in channels. There's the good old-fashioned session you know and love from HTTP, from the cookie. And what happens is when you open a socket, it's very convenient because it starts HTTP, the cookie comes through in that initial connection request. So we can actually take the session from the real site, drag it through into the WebSocket framework, and then stash it. But where do we stash it? Because, of course, that connection handler is on one of the machines. Where does it store the cookie for the rest of the thing? And so there's also a second kind of session called a channel session. And that channel session is basically your state for the lifetime of a socket. So imagine if you're writing a simple application in Python, you use local variables for this, right? Like, oh yeah, have a handler or a thread, it's in there. Instead, the channel session is a place where you can put things that happen during the socket and for the socket only. Like, oh, when someone connects, set their username, set their permissions, and that kind of thing. So that gives you sort of your general over the lifetime set of what you can do with the socket. And this is one of the things that powers the enforce ordering thing I mentioned about before. So, I said you can take a socket and you can enforce ordering on it using these sessions. And what this does is this decorator, which ships with channels, just looks at the message, uses the channel session and says, okay, I have packet number 5, what was the last packet handled packet number 4? And at the end of the decorator, it says, I just handled packet number 4 and writes it into the channel session. So what you get is, you get the thing where the first thing, so it's like, packet number 1 just runs, doesn't look for anything. It says, okay, number 1 runs, saves number 1 to the session, then number 2 goes, oh, number 1's been run, and it can then pick up and do it again and keep going. How this works, a little bit of interior information here. So inside the loop, inside the decorator even, that runs this is the sort of code we have. So this is in particular the session decorator to give you channel sessions. So the Django session framework, if you've ever used it, is interesting and quite old by now. And it kind of wants to do its own thing. Like the session framework goes, okay, here's your session key, put this in a cookie. Now we can't do that. There's no cookies in WebSockets. Or you can receive them, but you can't set them. So what we do is we go, no. Here's the key, deal with it. And the key is made using a predictive hash from that reply channel, that identifier that we have for every channel. And so we take that identifier. This first function on the slide here basically takes a reply channel name, hashes it, then forces the session framework to look up by key, and you get back a session. And then the second part says, well, okay, we have a session. We need to make sure it's saved, so it actually exists in the database first, so there's no collisions. And then when it's saved, it can then pass it back and continue. Now, the one interesting thing here is there is a raise consume later. The way that channels works is that it is a separate worker loop from Django. So normal Django runs inside a WSGI container most of the time. That handles your loop and your requests. Because channels run separately as a separate process, it has its own loop. It has a thing called run worker that happens and sits there and just spins around handling stuff. And the flow of that is, well, it looks for all the channels it can listen on, so connect and receive and disconnect. It says, give me any message from any of these channels that arrives first. And then the loop goes, okay, I've got this thing. It then looks in the routing to try and find the right consumer, finds it, then just runs the consumer, and then just finishes and then loops back around to the beginning again. But in there, inside that code, there's a little thing that says, but if the consumer throws the exception consume later, take the message, put it on the back of the queue and continue. And so this is your way we can go, I don't want to handle this one just yet, and you can put it back on. There's a couple of these exceptions inside channels, sort of a bit like control flow, like, oh, throw this away, consume it later, and sort of a bit more of that worker loop that we now have in place. There is no middleware, and this is a somewhat controversial thing. Some issues recently over this. So middleware is great. I agree with this. I love middleware. However, middleware is built with the thing where the request flows in through the middleware, the response flows out through the middleware. Now, because of the way consumers are written, which I'll remind you is like this, you don't return the response. You send it via a couple of different functions. You can do a group send, you can do a reply channel set, you can just send to an arbitrary channel name if you want to. And so what that means is you can't capture those easily at all. And so your middleware can't do the exit portion. And so for that reason, right now my position is decorators replace most of the cases of middleware, and they are more obvious because with decorators, you look at your consumer and go, oh, there's a decorator right there. I know that's being applied. With middleware, it's hidden away in another file. And I personally like explicit discoverable interfaces. I may eventually concede on this at some point, but right now, there is no middleware. It's all decorators. And things like authentication and sessions are all handled in decorators. Those things are there for you. Now, you may think that, well, Andrew, what about the rest of Django that still exists? That's still there. Django views are still there. Django HTTP is all well and good. But the fun thing is, because what I described as a superset of what Django does now, it actually builds into the current system. The entirety of Django, as you know it now, is a single consumer inside channels. It's called the view consumer. If you want to, you can just route requests to it, and they'll come through the view system, do URL routing, come out the back with a response on it, handled onto it. And this means that inside channels, you can just, if you want to, mix and match HTTP handling with, so let's say, long polling, which you can't do inside views. So, oh yeah, well, in my routing, if it's on the long poll path, send it after this special consumer for HTTP. If it's on the WebSocket path, do it over here. And then finally, if you want to, and this is on by default, just drop down to the Django view system. And this way you can mix and match different kinds of even HTTP handling and WebSocket handling with standard Django views. This is what that consumer looks like in very modified small format. It's really about 20 lines of code. But essentially, what it does is, right now inside Django, there's a thing called WSGI handler. That is a piece of code where you go, okay, here is my application. You load it in, then you just call it, because WSGI, you call and get a response, and you call it, and it gives you a response. Same thing applies here. There's an ASGI handler that can decode things from a message rather than WSGI environment variables. So we use that, and then we just take the replies, and then we just send the replies to the reply channel, and then handle them off. The one difference here is you can see another one of those exceptions. As I said before, channels have capacity. So imagine you're streaming a very large file to a client, and they've got a very slow downlink. They won't be able to receive the messages as fast as you're sending them. And we don't want the channel layer to have to sit there absorbing 100 megabytes of file into whatever buffer it has, and then doing it down again. And so what we have is, again, if the channel is full, in this case, rather than disconnecting, we just wait. We stop the iteration, and in particular, if you have like a chunked response or a yielding response, this works as you'd expect, where it pauses in that yield. And just waits, and then when the channel is empty again, it goes, okay, it's empty again, and continues going through. So you can do streaming responses in the same fashion you can with WSGI. Finally, in sort of the slightly quick whistle-stop tour of this, there are more signals and commands. So inside Django, you have a couple of important signals. Response started and response finished, in particular, are your life cycle of how a response works. And a lot of Django is built around, well, when the response starts, do some stuff. When the response finishes, clean up some stuff so the next response is done. In particular, closing database connections is done in the response or request finished handler. So channels introduces new signals. So the old one's still in there for the view system, but there's also a consumer started and consumer finished signal. And what it does, it ties in database cleaning to consumer finish as well. So your consumers won't leak database handles. And it also overrides run server. So run server bundles in Daphne and runs everything. So run server just has WebSockets now, just works as you want. And then finally, things like static files, which have like special development overrides in Django. You may not know this, but when you run server, a piece of code flips on and says, oh, in debug mode, override this URL config and inject static files in the middle of it. And we have to replicate that as well. And then finally, this is what channel is now, but what is in the future for channels. So hopefully you've got some idea of what it is, and kind of what underlies this is a generalized system for communicating between nodes. Channels design is, perhaps not surprisingly, based on CSP, a language I was taught at university for proving asynchronous and distributed systems. It is the idea that you can have a message passing system, and that's how you can reason about things and prove deadlocks. And what I've tried to make a system that is not just for handling WebSockets, but for handling generalized asynchronous problems in a larger system. Now, websites aren't just HTML anymore. They are different kinds of problems, different kinds of systems. You might have MQTT, which is an Internet of Things binary protocol for reporting sensor data. The Internet of Things is growing. It's kind of part of the web as well. We should be able to handle that kind of thing. And so what I'm trying to lay here is not only a good Django thing that looks like Django and feels like Django, but also an underlying system for Django and your wider projects, and maybe the wider projects of Python in general, for how do I write different processes to talk to each other in a way I can reason about effectively. And it's also not even for that inside Django. You can do, say you've got microservices. How do you send things to microservices? Ta-da, channels. You can do that. You can do things like separating things by CPU. So you say, oh, I want to run all the thumbnailing on this machine for these channels. I want to run all the things that have my signing keys on this one machine locked in a closet behind 25 gates. If you want, you can mix different Python versions. This is a way to convert part of your site to Python 3, because you can say, oh, well, these consumers run on Python 3, and the rest of the site runs on Python 2. And of course, you can run different parts sync and async. Underlying channels is the fact that what I've done is I've kept Django synchronous. Django still runs fully synchronous in a worker loop, and you still have all the things and all the same guarantees you had Django before. And all the asynchronous stuff is kept in a separate process where if you want to, you can go and play with that. I recommend reading up before you do. Asynchronous stuff is horrible, and WebSockets doubly so, but it keeps them apart. And if you want to, you can write your own synchronous processes, your own asynchronous processes, and tie them into that bigger system. Or you can just be like what I want to be and ignore it and be happy and just go, I can write synchronous code. This is great. And part of this is, channels is still a young project, especially by Django standards. And a big part of it is diversity of implementations. So I mentioned before, there are currently 3 different channel layers. There is a conformance test suite as well. I mentioned that. I quite like those in specifications. And a 4th one, hopefully being worked on very soon. And that's kind of part of proving this is I want at least 2 production-ready channel layers. Only one of them, the Redis one, is currently cross-network. I want at least 2 web servers that support this specification. Having Daphne is great, but the Django project is not really in the business of running a web server as well. So talking to other servers, trying to get them to integrate support as well, and having that be part of a wider push. And more optimization, like channels, is not the best at having lots and lots and lots of channels being listened on, because it sends them every request. It's not particularly good at bulk sending to groups. Both of these are solvable problems. And so, I believe in getting it right first and fast second. So, we're right and a little bit fast, but there's a lot of room there to get it faster and hopefully match or exceed the speed of current Django. Because at some point, I would like to have it be a no-brainer of we should run everything via this rather than just have sort of a split WSGI thing. And also, finally, more maintainers. I am, in many ways, the person who talks a lot about channels. I was very grateful that there were a couple of other talks at DjangoCon US this year that talked about it. But there are not that many people helping me to maintain the core project as it stands right now. And channels has a lot of problems that are fresh and range from easy to solve to almost impossible to solve, depending on how you're feeling. But also, we still have Mozilla funding, thanks to the very generous Mozilla program that I applied for after this conference last year, and then they just gave us some money to build this. So if you are at all interested in channels and want to help do a few bugs or write some documentation or write a tutorial or write some examples up or fix some horrific, nasty, reality-tearing things in the middle of it, all those are possible. Please just come and talk to me and I'd happily talk you through some of this stuff. And finally, channels has been going for a while. I am very close to calling what we have 1.0. It's not quite there yet. You may not be aware, but channels over the summer became an official Django project. So it's now at github.com/Django/channels. And so soon we reach a stable stage where you can rely on the API properly. It's not going to change much anyway. It's pretty stable as it is. And then from there, plan more what is the future, and maybe sort of start moving towards more of a date-based release system like Django has as well. And with that, that's the end of my talk. Thank you very much.
Thank you very much, Andrew. Predictably, we have a lot of questions.
Oh, great. How many hours we got left? Oh.
According to the schedule, we have 4 minutes.
Okay, right.
But that's mostly my fault for running over, so we'll run slightly over because there's a lot of interesting questions. Let's start off with something relatively straightforward. What are some sort of common use cases you can think of for why you would want to start writing channels?
Yeah, that's a good question. So not everyone has a need to write channel stuff. In particular, WebSockets are still somewhat new and not everyone wants to use them. So I would say that if you have any part of the site that currently uses long polling or sort of any kind of polling or any kind of live data, that's an obvious first choice. What I'm looking to do actually in the near future is implement something like sock.js, which is a layer that sort of encompasses long polling and sockets for like fallback purposes. And so what you can do is, we'll just use the existing JavaScript that somebody else is writing with the spec they have, plug it into Django, and then you can have easy live data on your site straight away. And a lot of more rich web apps want that kind of stuff. So that's a good first case, I would say.
Cool. So if you want to get involved with channels, is there like an equivalent of the Django tutorial yet? Is that a work in progress?
So there is a getting started guide. The documentation, which is linked right here, has a sort of, there's a sort of, a first document goes through the concepts in a sort of a more proper way than I have here on stage. And then the second document is a sort of a basic tutorial about, well, let's write a consumer, let's fiddle with HTTP responses, let's see what happens. It's not as good as any of the tutorials we have in Django, but it is a good start. I would love to see that improved if you're interested in helping out there as well.
So having gone through those documents at some point and built my own little channels testing thing, this is a question I'm particularly fond of. Why did channel paths start with a slash?
Wait, you mean in the URL routing?
In the URL routing section.
So the reason they start with a slash, so if
you're
you're not familiar, let's go back to the slide here. That's a good thing. So paths in channels start with a slash. In URLs and Django, they don't. The reason for this is, this actually is not URL routing. It is routing on attributes in the message. It happens that all the messages have a path in them and that you can use that. But you can also do like if these are HTTP, you could do method there, you could do reply channel, you could do anything you like, header-based routing. It's because it's not just URLs. I did want to put special casing for, well, if the name they look for is called path, then strip the first slash. So this is more of it's a general code rather than a URL code thing.
So, I mean, there's a DEP in progress at the moment about URL routing and improving that system in general. Do you think that this or more of an advanced system that you built might be applicable to reworking Django's own URL routing?
I would love to see the two of them come together as one system. I think having, I had to write basically a brand new one because the current one is not very flexible, but hopefully we could fix all of that in a new rewrite and have the same system shared between both of them with a flag that says, starts with a slash, yes, no.
How is this different to Celery or sort of quote-unquote normal message queuing?
Right. So Celery is a task queue. In particular, it is for offloading things to be done at some point in the future. Channels is a high-speed, basically like communication layer. So latency is a big difference, as well as so Celery is reliable and trustworthy, and if you put a message on there, it's probably going to get delivered. Channels is, but it might take a second or half a second to get there. Channels is, under a millisecond, really quick, designed for a very rapid chat, and so they're different kinds of systems. They both are kind of message buses, but many things are the same underneath. For example, I would say sending an email is probably best done via Celery if it's important, because Celery has more guarantees. But something like running some stats code is probably better done via a background channels task because it's much lighter weight. So there's a kind of a sort of a balance there between different design patterns.
I guess kind of building on from that, if you're going to do some things in the background like that, is there a way of making sure that particular connections or particular channels or so on are only handled by certain parts of your system so that you could load balance, you can run it all in one system, but you can load balance your different areas independently?
Yeah, so that is definitely in there. So the command you run to run a Django process, which is called run worker, there are options on that to say, you can say like, only run this pattern of channels, so like only run WebSocket.star, or don't run these channels, don't run HTTP.star. And so like, if you want, you can balance the process, say, this process handles everything but this channel, and sort of load balance that way. Like, these servers have more RAMs, we'll put thumbnailing over here, and then we'll put queuing over here, and we'll put handling over there. So you have that kind of flexibility in there.
Thank you. Has the HTTP over channels been load tested? Do we know whether this is better, worse than the situation we've got?
It has, thanks to one of our people who signed up to do some help. It has been load tested. It came out very slightly slower than GUnicorn, which, as far as I'm concerned, is not bad considering. And it's mostly because we are taking the request, re-encoding it, sending it over a network, de-encoding it, and doing handling on it again. So it is a bit slower. I would love to see that equivalent speed, at least in a sort of similar configuration. It also isn't as great at, so say you're like 1,000 simultaneous connections, it doesn't handle that as well yet either. So there's room for improvement there. But I fully believe it could get as good as that.
If you're looking at the performance of it, what profiling tools do we have available for distributed systems like this? How do we track how long it actually takes for a message to come in, go on the message bus, get processed, get sent out to something else? How do we profile this system?
We have disturbingly few tools for this. So for HTTP, you can obviously use one of the standard HTTP benchmarking tools. For WebSockets, there is one from the Node community we've been using. There's also one I've written as well, which is a bit more it's a bit more mean, sort of like throws in like random non-UTF-8 bytes and then changes the order around and tries to sort of see if they come back in the right order and stuff like that. But a lot of those, like part of this optimization is writing those tools, writing that sort of metric stuff to hook in and go like, well, what is the latency inside the ASGI layer? What is the end-to-end latency of the whole system? Like, is it slow in one direction? Like that needs a lot of work.
So debug toolbar for ASCII.
Yeah, it's on the GitHub issue list. Like there's one that says debugging things for ASGI. Yeah.
Within the spec, is there the capacity that it could at some point have a at least once mode instead of an at most once mode? And how many components are there that work on this principle? Could there be a different version of swapping some of those things in?
Yeah. So it's not part of the system necessarily. At most once is it's a guarantee that you have to code against. And so it's the way things are designed. You could do it, you could reuse the existing layers and interfaces, but all of the code on top, so all of the decorators, all of your consumers would have to be rewritten. So imagine you have a site that expects failure. So right now, channels expects failure, it's built into it, like the session handling cleans up after a while because it expects failure. And now you have to deal with duplicates. So now you need what happens if we send the same response back to the client twice? Do we need to write new client-side code to dedupe things? Do we have a dedupe store locally to handle this stuff? So it's possible, and a lot of the same things apply. It's just like one of those base decisions that if you flip it, you change the universe of code that comes after it. So maybe you could, and certainly you could just write a layer that did that, but you wouldn't be able to reuse a lot of the existing code.
So I had a bunch of related questions around the choice of particular things. There's lots of different things that you can use for a transport layer.
Of course.
There's lots of different infrastructure stuff that you could feed into this at the front end.
Yes.
If you've got a Slack input or whatever, is this expected that you need? What would be the process of implementing one of those?
Right.
And kind of related to that, what do you currently recommend that you use as your default stack to run this thing on?
Of course. So what you have is basically you have a what's called a protocol server. And that's the server that sits between the internet and the protocol you're handling, so be it Slack or IRC or HTTP. And then that talks to the ASGI backend and the channel layer behind it. And so for each of the things you want to talk to, you need one of those. So if you were doing a Slack integration, you run a Slack protocol server that sat there with its own process, with its own async framework that opened, I think they have WebSockets and HTTP API for Slack that opens those connections and does all that stuff for you. But the other part of it also is writing a spec because, you don't have to, but I highly recommend that you write a specification that you code the protocol server against. And that's kind of part of what I'm trying to do with email and that kind of stuff as well. As for the default stack, right now, personally, I would run Daphne for WebSockets only, and then route WSGI stuff, HTTP stuff to a WSGI server. So what you can do, you have Nginx, you can do a path separation and say, this path goes to this backend, this path goes to GUnicorn. That's how I would run it. My personal site actually runs just in full Daphne mode because there's nothing important on there. But once it hits 1.0 and we get a bit more stable, I would start recommending just run the whole thing through Daphne. And hopefully in future I can then say, or server X also has this support for this natively. I've been talking with a couple of the maintainers of different Python web servers to try and get that conversation going.
Great, thank you. Final question, although there are at least a dozen more questions I could ask.
I'll read through them.
So please do go through them all. I'm going to ask this one because it's coming from the live stream.
Ooh, hello.
So how do you send a message from a client through the socket to a new route? It's not documented anywhere, and said questioner has
So
been
how do you
struggling
send a
with it.
message from the client? Say that again.
So how do you send a message from a client through the socket to a new route?
I don't know what they're asking there, I think, is the problem. I need more context.
You'll need to go and ask that
Yeah,
one on YouTube
I'll go in the channel and try and answer that and get some more background on that one.
Great. Thank you very much, Andrew.
Thank you.
Aha. Break. So plenty of time to catch up and try and work out what's going on. Have some coffee. I'll see you all back here when the gong rings in approximately 25 minutes. Hello, everyone. Welcome back. Hopefully everyone's had some coffee or some drinks and is feeling raring to go for 2 more hours of talks. I'm going to start this session off with what I hope is an uncontroversial statement. Testing is a good idea. There's a whole collection of tools in Django to do your testing. So we've got test runners, we've got mailbox utilities, test databases, all kinds of things. And I wanted to have a talk that kind of gave us a tour of all of the things that you've got to test your code base with. There's a lot of them, so it was no small task. I'm delighted to welcome the wonderful Anna Balica. Anna is a serial Python conference speaker, Django Girls mentor, enthusiastic coder. The first time I met Anna was a couple of years ago, I think, in Cardiff at the DjangoCon, where she taught me a lot about mocking in tests. And I'm delighted to hear a lot more about what she knows about testing in Django. So please welcome Anna.
Thank you. Ooh. So I'll be talking about testing within Django and all of that. To be fair, I'm not an expert on the Django test framework, though, and I'm not exaggerating that, but I'll try to share as much as I know and keep you entertained for this talk. This is, in fact, my first time attending Under the Hood. All the previous times, the universe got me redirected to someplace else, unfortunately. It is fairly easy to find me on the internet. Nevertheless, here's my Twitter handle. I am a backend developer who writes web apps in Django, like all of you. I'm one of the potatoes. We are a web agency based in London, and we are mostly known in the Django world as the people who befriended Django's ORM with Appengen's cloud data store, and also the ones who created those cute Mesh light installations. I even got a specific color. I got a purple one. So I'd like to start with a quick run through the history of Django's test framework. So let's take a trip from version 1.0 to 1.10. About 10 years ago, sometime before Django was out of beta, before releasing 1.0, this ticket gets created. We are still at 4-digit ticket numbers, and this one is titled Add Unit Test Framework for End-User Django Applications. The ticket lists all the possible benefits of having an integrated framework for end users to test their Django apps. And there's this killer argument. As an added incentive, this is a feature that is present in Rails. I see the courtier is just having a blast. So that's how it all started. To be exact, it started with a management command, test. Test command accepts test labels. Labels at the time are pseudopaths, so you get app.testClass.testMethod. And this is the test runner. Test runner is a variable that points to a function that runs the test. Being exposed as a setting meant you could write your own test discoverer and runner. The test runner would set up the test environment and would look for tests in files named test.py and models.py only. So you might be asking yourself, why models.py? Because models.py contained doc tests that were very popular at the time. Doc tests were used to test ORM a lot. Models.py was meant to hold model and application-specific tests, sometimes spawning several screens of doc strings with tests. Everything else was left to test.py. At the very end, the test runner would tear down the test environment and return the results. Client makes its appearance in version 1.0 as a basic stateful browser-mimicking stub that constructs requests, passes them to the views, and returns a response, bypassing all the networking altogether by interacting directly with the WSGI interface. At its core, it's still the same client that we have today, just a more limited one. Another famous figure appears, it's the test case. Test case is essentially an extension of the unit test case class because it can load fixtures, clean the stub your mailbox, initialize the client, clean the data after each test. And it provides a couple of helper assert methods, which are still available today. Version 1.1 comes shortly after, and with a revolutionary set of HTTP methods. RESTful APIs are not yet the next big thing, but Django is looking into the future and decides to add put, head, delete, and options. Someone else makes its appearance. It's the transaction test case. This is when a clear distinction is being made what is a test case and what is a transaction test case. So the test case acts like a burger. It drops each test into an atomic block. So you enter a transaction, you run the test will do massive things to your database, then you roll back that transaction so that you leave a clean slate for the next test. Because of that, the test case class will prevent code from issuing any commits or rollback operations on the database to ensure that the final rollback at the very end will restore the database to its initial state. This refactor of the test case led to better performance. But what if you need to test code that involves transactions? Well, no problem, transaction test case to the rescue. Transaction test case is fine with you doing transactions. It will clean after each test by flushing the database at the start of each test. By the way, the previous version of the test case in version 1.0 was doing exactly that. 1.2 brings a couple of improvements and interesting features. Django defines a new interface for test runners. Those should be classes with a method called runTests that acts as an entry point. By default, Django provides this class, which is Django Test Suite Runner. There's a very subtle and interesting bug discovered in this period. So the test runner returns the number of errors and failures summed together. And what Django did, it would spit out the number of failed tests as a sys exit. So you've got 0 tests have failed, that branch won't be executed because of the if conditional, and that will naturally exit with a 0, which is success, that is fine. If you got 1, that would be a failure. If you got 42, that's a failure as well. 256 failed tests, whoops, this value will overflow into a 0. Respectively, 257 will overflow into a 1, which is going to be incorrectly a failure, but with an incorrect count. And talking from experience, it's not very complicated to get 256 failing tests or more. In fact, what is interesting when I was researching that is that system codes actually have meanings. For example, 130 means that the script was terminated with Control-C. But this was fixed, and how it was fixed by casting the number of failed tests to a Boolean. So what happens now is that we always get 0 for success and 1 for whatever number of failures we've got. On the next slide, you'll see that the Boolean disappeared is because Tim just today merged a patch that removed that weird way of figuring out if it's a failure. So let's just return 1. And with the new fix, 256 failed tests are always going to be a failure. Take a look at the definition of the test runner. Something changed from the previous version, and that's the fail fast. Whoops. This is a new argument that allows you to terminate the test run on the first failure that you encounter, and it's very handy. Ever since the implementation within Django has been removed because it's available in the Python unit test library. Django has support for multiple databases with a replication strategy. So you've got a primary database and multiple replicas can be created. This is how it looks like in your DB setting. So you've got your default database and the replica. And if this test mirror setting is missing, then during test there won't be any replication, just the default database will be created and tested against. So to simulate replication, Django allows you to set up a test mirror. At some point later, settings will be changed and get bundled together. So if you want to set up a replica, a test mirror, nowadays, this is how you do it. So back to what will happen when the test environment is configured. A test version of replica won't be created. Instead, the connection to replica will be redirected to point to default. As a result, writes to default will appear on the replica, but not because they're actually the same database, but because there is I said it the other way. But because they're actually the same database and not because there is some data replication happening between the two databases. So 1.3 brings joy and goodies. The test case and the transaction test case get two new assets. We see a split of the two roles that the test client embodied at the time. The role of manufacturing request was turned over to request factory, and obtaining the response was left to the client. Request factory became part of the public documented API. As we see from the diagram, the request factory is a parent class to the client, and this is how it is still nowadays. To me, and that is certainly disputable, this doesn't make a lot of sense because this is not a relationship between the request factory and the client. Those are two separate, conceptually, two separate entities. And also it ties the client to only one specific way of creating requests. So we can do better by using composition, and I'd suggest during sprints we could discuss any backwards compatibility issues with this problem or any concerns and maybe make it better. So how do we manufacture requests with the request factory? By creating WSGI request objects directly with a set of WSGI and request specific attributes. So like URL scheme, protocol, request method, payload cookies, and all of that. And there's nothing else that it does. It is simply a factory. So doc tests. In the beginning, it seemed like such a great idea. You get both tests and documentation. In the long run, it became a nuisance to debug. It also became apparent that doc tests aren't really good at providing neither high-quality documentation nor comprehensive tests. That's why doc tests will be discouraged to be used in the future. And this is a good example of a big project going through a love stage with doc tests and proving that this relationship just simply cannot work. There are two useful internal Django testing, useful for internal Django testing and for those who write reusable Django apps. There are two decorators: skip the test on a condition, or unless a DB feature is supported by database. So in 1.4, the family of the test case classes receives an expansion pack. We've got two new kids on the block. It's the simple test case and live server test case. Simple test case is lighter than test case and company because it doesn't hit the database, which means there is no setup teardown, there are no DB queries involved. Live server test case runs an HTTP server for you so that you can use a testing framework like Selenium. And it is based on the transaction test case. So we are halfway there. Version 1.5 is the time when Python 3 support lands in Django. The file about testing in Django becomes so big that we get a whole new section of the tutorial dedicated to testing and covers basic and more advanced topics. As usual, we see new assertions added to our test case classes, such as comparing JSONs and XMLs. So remember we talked about the transaction test case flushing strategy. And we said it flushes before each test. Well, other test runners become popular at the time and realize that there's a bit of a mass left by the transaction test case. Flushing the database before each test, it should be the other one. Flushing the database after each test case isn't that good of an idea, so it has been changed to flush the DB. Yeah, it's the other way. So flushing the database before each test case isn't that good of an idea, so it has been changed to flush after. So here's what happens. So you flush the database, and then you get, and then you run the transaction test case, then you run the test case wrapped in a transaction, and boom, you get dirty state right in there. This is why Django Test Runner is always rearranging tests so that test cases run first, and then the transaction test cases, and then eventually the doc tests. Transaction test cases leave a dirty state at the very end, but that's fine because the DB will be destroyed eventually. But if we flush after each transaction test case, we get no dirty state, and the problem is solved and everybody's happy. This holds true today. This is how it's done. In 1.6, patch is being added to the list of client HTTP methods, and if you thought the list is complete by now, nope, it's not. We see some other improvements to the testing framework. We get a new test runner that is able to locate tests not only in models.py and test.py, but anywhere from the installed apps as long as it matches specific file patterns. The new test discovery also means no more tests in models.py. Hooray. Pseudopaths are being removed, so there's no more app.testclass.testmethod, but real file system dotted or directory paths. This also allows running tests that are not inside a Django app listed in installed apps. And finally, doc tests won't be discovered anymore. Say farewell to doc tests. So in 1.7, 3 versions before, I haven't mentioned that, but 3 versions before, Django introduced unit test 2. Unit test 2 is a backport of unit test features that work with older versions of Python, like 2.4. And since at that time Django was supporting that version, it was vendoring the unit test lib. And in 1.7, Django dropped support for older versions, so we go back to unit test. An interesting split happens. At first, when live server test case was introduced, it was serving all the static files. At this point, live server test case will serve files only from the static root, simulating the real production environment. And if you want to serve any static files from your app, use static live server test case. Live server test case at this point becomes less powerful, but also it has less magic. And in 1.8, we get trace, and this is complete, and you won't see this slide again with the client. We are done. In version 1.8, test case suffers some important and intricate changes to how it runs tests. So before that, think that version 1.7. What test case did is, as we already know, wrapped each test into a transaction. So what it will do, it will enter the atomic block, it will load the fixtures, execute one test, exit the atomic, in other words, roll back the transactions, and will close all the database connection for cleanup. And that whole procedure will repeat for each test. Now with Django 1.8, before loading fixtures, it will enter another transaction which will be rolled back at the very end. So everything else that will happen will be sandwiched in this one big hug. This means load fixtures once, or use setup test data, also called a single time, and execute every test in another transaction as well, like this. And the first transaction will happen only once. What is the gain? Obviously the speed, because you don't need to load the fixtures every time, and you don't need to close the connections for every single test. In 1.9, support for parallelizing tests lands in Django. The tests are parallelized using Python multiprocessing module, which means it's mostly useful for I/O-bound tests. Obviously, tests should be as pure as possible, not trying to access any shared resources between the processes, for example, like files. And by the way, Django's own test suite is also being parallelized. So how does it work? First, it spawns a couple of workers. If you don't specify how many, it will just pick up the max number of cores that you have. Each process will get its own database. So therefore, if we have 4 workers, we're going to have 4 databases. Now, the test discovery builds a suite of tests. This whole load of tests will be partitioned into chunks of test case classes, preserving the order of the suite. Workers will pick up those subsuits of tests and run them. Once some of the workers are finished, they will report the result and pick up the next chunks until we are done with all the tests and return the final result. If you're stuck with a version prior to 1.9, then don't lose your hopes. There are other options, for example, like No's multi-process plugin. It's also using Python multiprocessing module, but the main difference between Django's parallel and No's multi-process is that you get only one database, and because of the shared state, there could be bizarre, unexplainable test errors and failures. And finally, 1.10 will introduce various improvements and speed-ups, but my favorite one is the tags. You can tag your tests, creating buckets of certain types of tests that you'd like to run together or exclude from the test run. Similar feature is implemented by other test runners like Nose and PyTest. So if you're not on Django 1.10, you always have the option to do the same with Nose Atrib plugin or PyTest markers. So we've been going through the history of Django test framework, and we've touched on different topics here and there. But let's see the flow of running tests, a test suite as a whole, and what happens when you run manage.py test, basically just nicknamed testbed. So let's split the testbed into multiple pieces and analyze each one and see what is happening under the covers. First, we invoke the management command test. So let's zoom in, and there's pretty much a straightforward invocation. So we get the test runner class, we create an instance of it by passing a bunch of options, and we run the test. So let's zoom in even more. Inside run tests. First line in run tests is setting up the test environment. This will include a bunch of things. So the main 3 key points of this method are setting up the Lockmem email backend, so that all email that we send will be stored into a stub list, easy to access and assess our assumptions about email sending. This is a very reduced email backend in its functionality. Django template render method is being replaced by an instrumented test render method. Before rendering, it will send a signal that is a way to let others know that the template will be rendered. And that's how the test client returns a response that has extra information like the template context and the templates that were used to render the response, because it's listening on this event. And finally, deactivate translations so that tests will respect your project's set language. Those settings are rigid and can't be configured from the outside. This is what Django does in a very closed way. So next step after setting the test environment is to build the suite of tests. The heavy load of building the suite is done by the Python unit test lib, but Django extends some of its functionality by allowing you to specify tags, patterns, debug mode, number of cores for parallelizing tests, etc., etc. So it builds a suite of tests. Think of it as an aggregation of all the tests from the current directory or from the test label or tag or whatever you provided. At this point, it's just instances of test case classes all collected in a single place and nothing more. So then we go and we set up the databases. We run the suite of tests. Running tests is completely delegated to the unit text test runner. And for the cleanup, we'll first destroy all the databases that were created, unless we said to keep the database. This action being delegated to the connection object. How it knows what exactly to destroy? Well, when we were creating the databases, setup databases function returned a list of all the DBs that it has created, and this is being stored in a simple namespace. Afterwards, tear down the test environment. It is essentially the reverse order of what setup test environment did. It will restore all the settings that it has modified initially by storing the original, because initially it stored the original values into a simple namespace object. So bring back the original email backend, the test renderer, and finally delete the state and the mailbox. And finally, return the result of the test suite by combining the number of total failures and errors. Those lines should look familiar to you at this point. Let's take a closer look at all the test classes and how they relate to each other. This is the hierarchy where the simple test case is at the very top. It's being subclassed by transaction test case, this one respectively being subclassed by test case and live server test case. And finally, the specialized version of the live server test case being static live server test case. Those class names are so long. Simple test case is very fast because it doesn't interact with the database. It has access to the client, though. Use it as a slightly more advanced version of the usual unit test case class. Transaction test case is not fast at all. It will allow database queries and transactions, and it will flush the database after each test. Test case is faster than transaction test case, but not as fast as simple test case. It will restrict database transactions because it runs each test in its own transaction. Live server test case acts as a transaction test case, and it will launch a live HTTP server in a separate thread from the other thread that's running the tests. And the static live server test case is a specialization of the live server test case that in addition to everything, will also serve all the static files. Client is an important utility for testing Django apps. The three core actors involved in browser mimicking are request factory client and client handler, though those are not the only ones, but just the main ones. We've talked about request factory having the most straightforward role. It constructs requests and it encodes data. That's all it does. Client, on the other hand, performs more actions. First off, the client object is stateful. It retains cookies and sessions for the duration of the client. It also does a few other things. If you remember, we mentioned that when we are setting up the environment, we are using an instrumented template renderer. Well, the client is listening to events such as template render to be able to set the list of templates and template context on the response object. Also, it sets on the response a couple of other things like the original request, the client, JSON, resolve a match. It also handles redirects and builds a redirect chain for your inspection. Another important player in the game is the client handler that inherits from the HTTP base handler. The main goal of the handler is to return a Django HTTP response with the WSGI request attached to it. It will load all the middleware set in settings. It will disable CSRF checks, which can be enabled back if you want to. And it emulates as close as possible server and browser behavior by stripping down content for some of the requests, same as browsers do. And it will send a signal that the request has started. And this is it. We've talked about what are the tools that Django provides for testing. But how do we achieve quality in our tests? How do we make sure the tests that we write are reliable, future-proof, and are fast enough? Reasoning about quality isn't easy. Besides human understanding of quality, there are actually some of the tools that can help us. So let's start with something very simple. Introduce Factory Boy to your tests. Lots like it because of its shortcut methods for creating models. In fact, it doesn't do that with some static fixture-like data, but rather with some random yet realistic data. For creating that, it relies on another library called Faker, or Fake Factory in the past. Faker has a bunch of providers that, based on certain rules, create this random data. The important part, though, is that every time you run your tests, you will get different values. And there is a slight chance that this library will catch a bug for you. If you're interested in this kind of stuff, I'd suggest looking into Python's hypothesis library. It's a library that does property-based testing, and it takes the idea of the random input to a whole new level. Property-based testing came initially from a Haskell library called QuickCheck. And Hypothesis is the Pythonic implementation. It uses a decorator called given to inject randomly generated data into the test, the values being based on specific strategies, for example, in this case, based on the text strategy. Strategies are similar to Factory Boys or Faker's providers. It will run this test, so the tests that get are decorated with the given. We'll run the test multiple times, about 200 times, with all sorts of edge cases data that easily slip away from developers' attention. Since Django is an established way of doing web in the Python world, Hypothesis comes with an extra module called for support of Django. So similar to Factory Boy, we can create models populated with random data. To be noted, when we're using models.example, Hypothesis will always save the created model. So this is a real-world example, and I know it's a lot of code at this point. I'm not asking you to read it straight away. This is a real-world example of how Hypothesis can be useful for testing Django apps. If you look at the very top, the most important bit from the imports is the usage of the Hypothesis test case to be able to wrap each Hypothesis test into its own transaction rather than running all 200 of them into a single atomic block. So let's throw away the imports and focus on the test. This is a slightly stripped down example that I borrowed from a presentation made at the Django local user group in London by the author of Hypothesis, David. So what we're testing here? We're testing if the project model instance is able to respect the limit of users a single project can have. So the first thing we do, we use the given decorator and we inject one project model instance and a list of random amount from 0 to 20 of user models. Then we check if the project is at its collaboration limit, and by trying to add another user, we expect an exception to be raised. Otherwise, adding users should work just fine, and we can check if the user is a member of the project. Hypothesis will run this test multiple times, and if it will encounter that the test didn't succeed with a set of randomly generated data, it will shout at you falsifying example. A project with a limit of 1 and 2 new users, where the second one didn't trigger an exception, is a falsifying example. Yes, I know, DOM tests suddenly became very complicated. For testing this, we had to add a loop and a couple of conditionals, and it seems like this test might actually need tests for itself. But when used properly and timely, property-based testing can be a very valuable tool. Test code coverage is probably the most known and widely used metric. I can tell you that at this point in Django, the test coverage is 76%, more or less. And here's why I don't like code coverage. It's generally a very deceptive metric. If I have low code coverage, then yes, I probably need to write more tests. But if I have high code coverage, that doesn't mean anything except that I've hit at least once every single line of code. Though 76% mean that 76% of code lines were hit at least once in any way, and it doesn't matter how complicated are my lines. Code coverage is not suitable for assessing the quality of tests. High code coverage simply doesn't imply high quality of tests. And we can do better. We can do better with a different concept called mutation testing. Mutation testing isn't a new concept. It has been around since the 70s. What it does, it involves changing the source code of the program in small ways and observing what happens when we run the tests. So just think about it. This is such a powerful tool. In Python, mutation testing is implemented using a package called mutepy. Mutepy does the job, but it hasn't been updated since 2014. As I imagine, there isn't a lot of excitement around mutation testing. So here's how we invoke mutation testing from the shell. Say mute.py, and we specify the target, which is going to be our source code that is going to be mutated, and the unit test that is testing this specific piece of code. Say our target source code has this if statement with a logical operand AND. If foo and bar, then something should happen. MutePy takes this logical operand and inverts it from an AND to an OR. So our target source code becomes a slightly modified version of the original. And we call it a mutant. Now we run the test on the mutant. If the test failed on the mutant, this is good. We say the mutant was killed by our tests. This will add points to our mutation score. But if the mutant survived and has a happy smile on its face, then our test isn't good enough. It means that it doesn't really matter whether we use an AND or an OR, our tests will pass anyway. We are not testing it properly. And MutePy can do a lot more. There's a fairly long list of different mutants. It can replace arithmetic operands, break continuous statements, conditional operands, constants logical operators. It can delete whole conditional branches and remove decorators, and a lot more. This is what a stripped-down result of a test run with MutePy looks like. You get a mutation score, which is a percentage, similar how you get it with code coverage. It also tells you the total amount of mutants, number of killed mutants, the ones that survived, incompetent, and timed out. So what I did, I took this tool and started playing a little bit with the Django tests. So I'll share some of the results that I got. There is a pleasant trend, which is the correlation of high code coverage with high mutation score. So for example, the duration utils from Django have 89% mutation score, and they have 91% for code coverage. But that doesn't hold true always. For example, Django encoding utils, mutation score is 32%, while the coverage is 63% if we run only that one unit test. So this is somewhat okay coverage, some might say, but it has poor quality, according to mutation testing, obviously. Django tutorial is excellent. Beginners don't need to search the internet for videos, articles or courses on how to learn Django because of the Django official tutorial. Third-party documentation gets easily out of date and is rarely updated. So therefore, part number 5 of the Django tutorial is dedicated completely to testing. So just think about it. Testing is such an integral part of learning how to use a framework. One of the biggest reasons why developers are not testing is because setting a test framework and building all the test-based code takes time and is tiresome. So it becomes a low priority. So when you create a new app or start project with Django, it's basically shouting at you, hey, I created a test file just for you. Do you want to start writing some tests? Testing framework became a very powerful tool to motivate people to write tests, especially beginners. So Django tutorial contains a section called When Testing, More is Better. It says that yes, soon enough, once your project will grow, you'll see that your test base will grow even more, and it might seem like it spins out of control, but just let them grow. When testing, more is better. I agree, but there's a trap in there. What happens when testing more is better is that with time we will see an almost exponential growth of the number of tests. We rarely delete test code. And since Django gives us all the tools and encourages to write functional tests, the speed of our test suffers. Same correlation exists between the number of tests and the total execution time. The more tests we have, the slower our total test run will become. This is what happens when we run functional tests only. And this has all the implications. Slower tests means slower feedback loop. Therefore, I assembled 3 tips on how to speed up your tests, and number 5 will shock you. Use a faster and less secure password hasher. That's what Django does for its test also. Consider, and I emphasize consider, not use a SQLite in-memory database. For anyone who doesn't do any fancy stuff with the database, you might be just fine with it. Everyone else who has good reasons to test against a proper database, continue doing so, accuracy over speed in this case. Write more simple test cases when possible and use setup test data if you don't plan to mutate on any of the objects that you create in this method. Use mocks everywhere for all the database interactions. Obviously, I'm kidding. Be careful what gets created in setup. It might be the case that only a small percentage of the tests in the test case actually need those 7 types of users with custom set permissions. Don't save model instances unless you really need to do that. And finally, isolate unit tests. And I would like to talk about the last 3 points a bit more. So the tight loops might be an indicator that maybe this is not such a good idea to create objects and save them to the database in a loop. So identify, remove, or reduce the usage of those as much as possible. Instead of doing create, maybe you could just use an in-memory model. Similar to that, you can also create an in-memory model with the build method or the stop method, and the last 2 are part of the Factory Boy API. The caveat here is that you can't do that if you have many-to-many relationships. If you don't, it's much easier. And isolate unit tests. Your test suite might look something like that. It's a mix of somewhat unity tests and functional and integration tests all in one place. It would be more useful and would allow creating a faster feedback loop if we separate unit tests from the rest. Because unit tests are very fast and we can run them very often. One way to do is to use simple test case for unit tests, and you can also tag them with a special label. Even better, you can make them simple unit tests or PyTest, which have no idea what Django is, and write more of them. At the same time, don't neglect functional tests, because obviously that's where we validate the contracts between the units. Say you decided to switch jobs and run a little bakery. What a great decision, I must say. And reminiscent of your previous jobs, building apps, you decide it's going to be easy peasy to create a web app to help you out with your little business. You decide to build a feature to help you out with setting the correct VAT, which is a value-added tax value, to your products. This could save some time for the accountant because EU taxes. So let's start with a basic schema. At this point, it's not necessarily the best, but you've got your product model and your product questionnaire model, and there's a one-to-one relationship between the two. The product questionnaire is the key to your VAT decision-making. It's a little add-on where we define basic yes or no questions and build a decision tree to eventually land on a defined answer. Is this product zero rated VAT, or is it standard rated VAT? So we will need a view and a model form. The view will display the questionnaire. The answers will be saved on the model for possible future recalculations. In the same view, we will converge to a final decision and save it to the product instance. With a known VAT, it will be very easy to compute the final price of the product. So I'll be showing example code where, for different solutions, where on the top we'll have production code, and at the very bottom we'll have the test code. So solution number 1, in the view, when we know that the form is valid, we check if the product is a biscuit and is it coated in chocolate. In that case, let's set the VAT to 20%. As for the test, we will create a product object, we will make a post request, and we will fetch the product back from the database, and we'll check if the VAT was set to 20. In reality, we understand that the if-else is going to be much longer. We can split it up in multiple methods. The essential part is that the entry point to this calculation is going to happen from the view. And for each branch, we'll have another task, and each task will have to create a product object, and we'll have to create a product questionnaire as well. And that will be repeated for each one of them, for bread, biscuits, and flapjacks, and all that. So to test, if I need to set 20% VAT for biscuits coated in chocolate, I need to go through the router, I need to interact with the database to eventually send an input and receive an output. And if you're thinking that to remove the database interactions with mocks, no, this is not the right solution. Let's try again with the solution number 2. The conditional check gets moved to a more appropriate place. It's the form. Hence, for the test, we will also need to create a product object, and we will be passing the data to the questionnaire form directly. We'll validate it, save it, fetch again the object, and check the VAT value. Even though we need to create a product object, we no longer are testing the routing, which is better. And then via the form, we are sending the input, answers to the questions, and receiving an output. The last and final solution is to move the entire decision-making into a plain old Python class. Somehow we forget that Django is a web framework and not a programming language. And different constructs can live outside the core Django components. The VAT calculator at this point has no idea what Django is, and it doesn't even need to. Decoupling has various benefits. Code reusability. If I decide that, well, my decision tree is quite good, and maybe I would like to share it with my friends and create a separate web app. Extensibility. If I decide to expand my business to a different country which has different VAT values, then it's going to be much easier to update them in a single place where the VAT calculator lives, rather than finding the codes related to it splattered all across Django. And finally, testability. There are no more routers, there is no more database. It becomes as simple as send an input and receive an output. This approach of isolating business logic allows creating more and faster unit tests and keeping the functional and integration tests at a manageable rate. Tests have more in them than we think. A test has the capability to drive a better app design. In terms of Django, it's about moving complex logic away from any Django-related components. If it's a complex behavior that isn't tied directly to your database or your templates or forms, not even mentioning views, which should stay very simple, then build objects that perform those complex actions and unit test them. Thank you very much, and happy testing, everyone.
Thank you very much. We have a bunch of questions and about 10 minutes, so we'll see how we get on. Let's start with... there's a lot of work, obviously, in these myriad of test case classes and so on. And a lot of this is potentially duplicated in systems like Nose and PyTest. Do you kind of have an opinion on why we need to have our own test runner at all, whether we should do within Django? What do you think?
So the main problem here is that I haven't used PyTest, and I know this question would come up, so I don't know about the capabilities of the PyTest, but at the same time looking at all the code that Django does to kind of bring up the whole test bed for the testing environment is quite Django specific and tied to some of the internals, which it needs to do in order to run the test. So I feel like it could be stripped down, but we can't remove it altogether. We can't even do it, I think, because of the backwards compatibility issues. We won't just say, we won't be supporting that anymore.
So what do you think is missing from Django's testing toolset? What we went through everything from 1.1 to 1.10. What should be in 1.11? What should be in version 2?
We probably might get easy pluggable components, for example, for setting up your testbed, to having a different mailbox stub, which will be much nicer. So I asked Andrew, and with channels we will get a bunch of new testing capabilities as well. So we will see some improvements there as well.
The hypothesis-based testing, the property-based testing looks like a great idea. Obviously, you said about dealing with the performance with the ORM stuff. How bad is it when you start doing that with the ORM as well? Do you think that's a good idea, or are you just digging yourself a hole to do property-based testing with hitting the database at the same time?
I wouldn't do property-based testing with hitting the database. I would just leave it for more unit-tested tests. Probably even with the SQLite in memory, it might be still very slow to wait for 200 tests to finish. So you would think you would isolate the critical components of your production app, and if you want to have very good, reliable tests, you might do that and then just run them on a CI if you're fine waiting for them.
How can Django sort of encourage developers to code in that way, to pull their logic out into other systems rather than putting it all there? Do we recommend advocating that?
The entry point for that might be documentation, mentioning, so there is nothing in the docs that says maybe every single component of the Django could specify that, you know what, this kind of things shouldn't be living here. For example, being more explicit about the views, not bloating them with every single possible type of logic. I know it already discourages complex conditionals or behavior in the templates, basically by just stripping down and not allowing doing that. I think probably documentation could be improved, and that could be worked on during sprints.
Great. I suppose in order to, when you've got an existing test suite that's big and has got lots of tests in it, how do you go about finding out where your problems are, and how do you know, I've got a test suite, I run it, it takes me 20 minutes to run my test suite, what do I do now?
The tests are probably isolated by modules, so you can run modules separately, find out if it feels like some of them are being too slow. With the setup, you will see how you can easily identify if you're having too much interactions with the database. If you're creating a lot of objects, for example, in the setup, is that when you will be looking at the dots that appear as success, you'll see that there will be a very big gap. And if you see it constantly for a big chunk, it means your problem is there. So just by observing it, some of the tests might be as slow as you actually have to, a couple of seconds for a single test to complete.
So obviously one of the other places where you spend a lot of time setting your tests up is within this testbed up setup. The testbed setup and teardown time. Teardown's quite quick, but setup can be quite slow. What are your thoughts on the fact the test runner runs all of the migrations each time you set the test suite up?
I work with the data store. We don't have migrations, but for everybody else who uses a proper database, a relational database, I don't know if there is a workaround not running migrations for every single model that you have. Would it make a difference? So I don't know here. When you've got a bunch of migrations, so you've got like 10 migrations, so the Django will run each one of them?
No, it just runs all of the migrations at the beginning, but it takes a lot longer than a sort of old-fashioned syncdb setup, where it just flushes the current state of your models.
Could it be possible to concatenate all of the migrations into a single one, and then you have to run only a single migration?
There is a way to do it. Yeah, because we use that in Django's test suite ourselves, don't we? There's a magic button you can press, and it's a documented magic button you can press. The other thing you can do is use keepdb, which saves you a bunch of time on at least successive test runs locally. Again, that doesn't really work with App Engine, so. Cool. So when you've got multiple test databases, you've got multiple database system. How can we set it up? Django only flushes the default database every time. Do you have any recommendations about how to work around that problem?
If you want to flush all of them, then you have to basically rewrite the cause. You can't just easily do that. That's why if somebody, that is a good thing that somebody actually has a proper use case that, you know, I would like to have a different flushing strategy because I am testing against multiple databases. So I think we just need to look into the core and make it more pluggable, separate some of those things that people want to have access to. You can't do it right now just easily, sorry.
What tools, tips, or tricks do you have for testing with files, especially image files or so on?
Ew. Ew.
I have this problem all the time. I work at a photography website.
I've seen, I think, people trying to find out solutions like if you're testing with PDFs, you're just going to have a very minimum kind of test a folder with some test file, and you'll have like the minimum possible super tiny PDF file or an image, a JPEG or whatever.
Muck around with your storage backend is another good approach. Sometimes.
But yeah.
And finally, what do you think Django could do to improve its own test suite? You know, sort of taking all of these ideas, you mentioned a bunch of things like Factory Boy and Hypothesis and so on. There, do you think we should be using these to make Django's own test suite better and make it faster as well? Because it takes still quite a long time to run.
It takes about 10 minutes parallelized. Yeah,
depending on which database.
Oh yeah, that is true. But you have the CI, you have Jenkins, and it all runs there, parallelized with multiple machines. Yeah, I think looking at the Django test base, it has a lot of unit tests, so I think it's much easier to start using Factory Boy or Hypothesis. Why not? Maybe we could write some special decorators that could run that only on CI and not on local environments for developers on their own machines. The test base is quite big, I would say. There is a lot of stuff in there, a lot of regression which needs to be there, but maybe we could go through and identify some of the things that could be improved. I'd love to do that. Like if somebody is interested, let's do it during sprints.
Excellent. Thank you very much, Anna. As you will note a recurring theme, I will forget about the speaker gifts after every talk. So, for our last talk of the day, I am delighted to welcome one of the most prolific Django contributors. Your resume includes time zones, transactions, Python 3, multiple template engines. Basically, an awful lot of what got Django from 1.2 to where it is now was thanks to Aymeric. If this wasn't enough to keep him busy, he also maintained Django Debug Toolbar for a while. And he's here to talk about debugging across your Django application. I couldn't think of anybody better to bring. Please welcome Aymeric.
Hello, everyone. Are you still fresh after 2 talks, ready for the third one? Okay, so just before I get started, I would like to thank the organizers because they've been putting a tremendous amount of work into this conference. And from a speaker's perspective, it's great. Everything is perfectly organized, so congratulations. I would also like to extend some special thanks to Mark, because Mark came to me last year at Django Under the Hood and told me, Aymeric, I'd like you to do a talk next year. And so I said, fine. And then he comes back 6 months later and he says, Aymeric, I'd like you to talk about debugging. And I say, fine, there's certain people who've never done any debugging. That's totally not what they do 6 to 12 hours a day. And so I'll certainly be able to teach them something about debugging. So yeah, A+ idea. Goodbye again. So I decided to reduce the scope just a tiny bit, and I will merely tell you everything there is to know about debugging performance, which is a significantly smaller topic. That will fit in an hour, but just wave your arms like this if I
talk too fast, and I will make an effort to slow down. Okay, and by the way, did you spot the bug? Right there, that's the bug. It's hidden. Okay, let's get started. I'm Aymeric. I've already been introduced. I'm busy creating the first collaborative peer-to-peer insurance broker in France. This is a slightly complicated concept, but we want to make insurance much better than what it currently is, and we can talk about this later if you want. So, before we talk about performance, it's important to think about performance from the user perspective. And for users, performance is usually pretty much the same thing as speed. So is this thing slow? Is it just regular speed? Is it too fast and did it overshoot the pond? Well, with computers, we can measure speed, or more precisely response times accurately, but it isn't always obvious whether the figure means fast or slow. For instance, let's say 500 milliseconds. Who thinks 500 milliseconds is fast? Raise your hands. Okay, nobody thinks it's fast, and you're all right, because fast is below 100 milliseconds. So there was some research by Norman Nielsen, who are some of the gurus of user experience, and they say that below 0.1 second, it feels like the system is reacting instantaneously, and so you can just display the result, and your user will feel like they're in control. Of course, often this isn't possible, and up to 1 second, all is not lost. Responding within 1 second will not interrupt the user's flow of thoughts, so they will stay entirely focused on the task at hand. And likewise, you don't need to give special feedback on the fact that the machine is working. You just display the result. If you're slower and up to 10 seconds, the user will still stay somewhat focused on what they're doing, but you have to provide some feedback that the system is working, especially if they can't predict the response time, because it's always 3 seconds, and so they know they have to wait 3 seconds. There's nothing above 10 seconds, because the user has gone checking their email or Twitter, and you lost, so sorry. So, from the user's perspective, and as web developers, the first contact with our product is when they're waiting for the website to load. So there's a blank page, and it's loading. And you don't get a second chance to make a good first impression, so you have to optimize that, and caching is not going to save you for the first access. Usually, page loads are in the 2 to 10 seconds range, unless you Google, but not everyone Google, which means it's going to be in the slow category for most users, and that's why it's particularly interesting to optimize. And I'm not even talking about mobile devices, where you're in the more than slow category most of the time, but well, that's what we have at this time. To optimize something, we have to measure it. And so we need to learn how to measure page load time. And we'll start, well, fortunately, it's 2016, and we have performance.timing, which gives us all the data we need. This is available in IE 9 and above, as well as all modern browsers. Unfortunately, it's very impractical for human consumption. It's Unix timestamps. You may also have come across this panel in the debug toolbar, the time panel. I don't know if it's really used regularly by developers, but it shows pretty much the same data here. This is extracted from performance.timing. But this is not going to help very much if you don't understand what these lines mean. And also, it's not going to help very much because this is running on your development laptop, which is not at all representative of production. So how do we get this data in production? You can use the Chrome developer tools, which have the option to throttle the network. And so you can make somewhat more realistic measurements, but you still have your powerful machine that's running Chrome, and it's not quite the same thing as a cheap Android handset from 3 years ago. So a better option is to get the actual data from your users, and usually the best way to get it is through a Google Analytics site speed, if the website uses Analytics, obviously. And then you can also slice and dice it by, for example, device, by geography, etc., etc. So you can really understand what your user experience is like. It's sampled on just 1% of your users by default, which may be a bit small for a small and medium website, but you can increase this. That's a trick, just Google it. You also have application performance monitoring solutions. These are usually commercial products. I'm not going to discuss them in detail, but they give you that information. So what's important for the timing? It all starts at navigation start, and the current page is going to unload, and that's reported, but you don't really care about the current page unloading. What matters is next page loading. The first step is redirects. If you have HTTP redirects, they're going to take some time, and this is reported. The next step is the app cache. So this is for doing progressive web apps and things with web workers. And if you want to talk about this, talk to Adrian, because he knows this much better than I do. So this will not matter for regular HTTP applications that don't take advantage of these features. Then the next step is to make the DNS lookup. So the browser knows what server it's going to talk to, and this can take a surprising amount of time. It depends both on the quality of your user's DNS, which is usually provided by their ISP, and which can be pretty bad, and it also depends on your own DNS, and if your DNS provider was chosen by your legal department because domain names are intellectual property, you might want to look into the performance. Now that you know the IP address of the target server, you're going to establish a TCP connection. Since you're running on HTTPS, you're going to need a TLS handshake to establish a SSL connection. And this can take between 2 and 4 round-trip times, depending on how many packets are exchanged. And so this is mostly sensitive to the latency between the browser and the server. Next, we are finally sending the HTTP request. We're requesting the page. There's a request start. There's no request end for a fairly fundamental reason, which is you can tell when you have received some bytes from the network, but you can't quite tell when you have sent bytes to the network because there's tons of caches and buffers and there's this EOS, etc., etc. So it's very hard to determine when you've written things to the network. This comes up in all async systems. However, you can tell when you get the first byte of the answer and the last byte of the answer. This depends both on how fast your server generated the answer. So now there we hit the backend. We're in Django land. And it depends on how fast the network is between the server and the user. And then the browser is going to do a ton of stuff, and I will discuss this more in detail later, but all this is just to display the page on screen. So the lesson here is that these things depend a lot on the network and actually not very much on your backend. And no matter how much you optimize your backend, you're still optimizing about 15% of the total page load time, which is a good or bad news. As a backend developer, at least it's not your fault, but then you have to go fix some JavaScript, so can't win every time. I made a few benchmarks with a cold browser cache. DNS is cached, nothing else is cached. And for example, for my content company's website, which is the most trivial website you can imagine, the backend takes 23% of the page load time, and I don't have a front end to speak of. Then if we look at a slightly bigger website, facebook.com, logged in, so I get a page that's very customized for me, and that can take some time to generate. We're around 20% of the total time that is spent in the backend. And then there's a ton of styles and images, etc., that get loaded. And the Facebook guys are supposed to know a few things about front end, and it still takes 15 seconds to load for me on my own connection, which isn't very good. And if we look at an editorial website, so this website, I'm not logged in. It serves the same content to everyone, so it's faster in the backend, and the backend takes only 10% of the page load time. I didn't have an ad blocker for this, to be honest. So yeah, what happens here? What happens is that HTTP 1.1 is fairly bad at fetching tons of things, and we've created many workarounds over the year, both in the browsers. The browser use DNS prefetching, TCP preconnect to speed up future connections by making them speculatively. They use connection keep alive and pipelining, that is sending a second request in the same connection before they get the response to the first request. they open 6 parallel connections to the same server, and of course they cache as much as they can. We, as developers, also do things on the server side. We concatenate our assets, we minify them, we can use a spriting for images, we can inline images in CSS or CSS in HTML. Some even used to do domain sharding. At the time, there were only 2 parallel connections, so you had static 0, static 1, static 3, static 4, and then you had 8 connections for your static assets. That's awful. And of course, we try to help the browser catch our assets. By the way, small digression, the only proper way to cache JS and CSS is to put a hash of the file content in the file name and set it with an infinitely long validity time. And when the content changes, the hash changes, the file name changes, and the browser fetches a new version. This is the only way to do it. You can do it either with your front-end toolchain or with Django's manifest static file storage. End of digression. So now that we've seen that it's not quite a problem with the backend, let's talk about the frontend. You can't do much about the network between the user and your server anyway. Once you have a CDN, your user is on a crappy 3G connection, that's it. You live with it. And I'm going to give a few more details about that part which I skipped earlier. So in the timestamp reporting by the browser, you have 3 steps which mark changes in the property which is reported under document.readyState. And these 3 steps are DOM loading, DOM interactive, and DOM complete. I'm going to detail them just later. And then you have 2 events that are fired during this process. It's DOM content loaded, and performance.timing reports the start and end time for the processing of that event, and later load. And likewise, the start time and end time are reported. So it looks like this. First, once the browser has finished downloading the whole HTML response, so the response to the initial request, it sets document.readyState to loading, and it starts parsing the HTML. So there's no event at this point because you don't have any JS yet, because you don't even have any HTML yet. You haven't started parsing it. While it parses the HTML, if it encounters some JavaScript, it will execute it. And when it gets to the /HTML tag that terminates the document, or to the end of the document, basically, it moves document.readyState to interactive and fires DOM content loaded. So this is the earliest point where you can consider that the page has loaded, and you can run some code of use. You could also run it earlier while the DOM is loading, but this is perhaps not the best idea because you want DOM loading to complete as fast as possible. So once you're in the interactive state, the browser may still be getting some CSS. Well, not really. We'll talk about this later. But it may still be getting some images, which can take some time to load, especially if it's a long page with many big images. And once it has finished that, it will move to the complete state. So complete means I have fetched and loaded every resource that was referenced by the original HTML. And it means the page is fully loaded. But it's a bit of a lie, because with modern websites, most often we'll have some JavaScript doing stuff after the initial page load. We'll have an AJAX request to populate part of the page. So this concept of loaded is a bit fuzzy, and you shouldn't consider load to mean my page is ready. It depends a lot on the applications. There's no general rule. So the timeline I showed earlier can be interpreted like this. Initially, you load the HTML. Here I have the fastest redirect ever. It's an HSTS redirect, HTTP strict transport security. This means that the browser knows that fractal ideas must only be accessed over HTTPS, and so redirects by itself to HTTPS. Do this, you can save up to 500 milliseconds on your page load time. Then, once here it gets the HTML, and when it has the HTML, we're at DOM loading, and it starts fetching all the JS and CSS here. when it has fetched and executed the JS, it reaches DOM interactive and fires a DOM content loaded event. And when it has finished loading the rest, so in this case an image and a font, we're reaching DOM complete and the load event is fired. And it's a really good thing that I did this talk, because then I could check my own code and run my JavaScript on DOM content loaded instead of load, so it runs earlier. So this is a very, very common mistake. You don't need to wait until all images are loaded to run some JavaScript. So that's the general idea. And now we're going to dive in a bit more and explain how browser load pages, what works they do in this period. So basically, you have some CSS. This is a very beautiful piece of CSS. And then you have some slightly more confusing JS somewhere in your page. And you all know that you put the JS at the top and the CSS at the bottom, and then it's perfectly optimized. So you have about 50 tracking scripts hiding in the bushes there, but it's fine because it's at the bottom. So it doesn't slow down your site. Everyone does this, right? Well, it's a best practice, and I'd like to explore a bit why it's a best practice. At a high level, all browsers have a rendering pipeline, and this is sufficiently high level to be accurate for Firefox and Chrome at least. So they get some HTML and CSS from the network. Things we get from the network are shown in green on this diagram. Then they parse the HTML and build something that's called a DOM, which is just a data structure representing the HTML so the browser can manipulate it. It does the same thing with the CSS to build the CSS arm, and then it merges them in something called the render tree. So the render tree is pretty much the same thing as the DOM, but it's annotated with the style information taken from the CSS. Then once the browser has this, it can calculate the layout, that is what goes where on screen. As you can imagine, this is fairly expensive to calculate the position of every item. And to do this, it needs fonts, which depending on your browser, can be loaded either when they're referenced in the CSS, i.e. does this, or when they're actually needed to render the page, Firefox and Chrome do this. So it's a trade-off. Do you want to fetch them earlier, but perhaps fetch fonts that aren't needed, or fetch them later, but possibly delay the rendering? And once it has the layout calculated, it can paint things on screen, and then you can, at long last, see the pixels that represent the web page. If you have some JavaScript, when it's executed by the JavaScript virtual machine, it will modify the DOM or the CSS arm, and the page will re-render, and the browser will update these structures and do a repaint. So what matters really in this process is what's called the critical path. So that's the sequence of events that is a bottleneck for showing your page. And this is how you can represent it visually. Basically, you need a DOM and a CSS arm to build the render tree. To have a DOM, you need some HTML. To have a CSS arm, you need some CSS. All this is fairly obvious. And then if you have some synchronous JavaScript into the DOM, so that is a script tag that contains some JavaScript, or script as rc equals something that loads the script, that script will be downloaded, if it's remote, executed, when the CSS arm is ready. And the reason for this is that JavaScript may access the CSS arm, and so JavaScript execution blocks on CSS. So this can cause some surprising delays, and it's something you have to be aware of when you're trying to understand why your page loads like this. And then once the JavaScript is finished executing, the DOM can complete, and you're there. So for those who prefer the text version, this is the same thing written differently. We need a DOM and a CSS arm, which require HTML and CSS. Building the DOM blocks on synchronous JavaScript. Executing JavaScript blocks on the CSS arm. But I didn't mention the reason why executing the DOM blocks on SyncJS. It's really a backwards compatibility thing. The JS could call document.write, which would have to be reflected immediately into the DOM. And so the browser cannot continue building the DOM until it has confirmed that the JavaScript didn't do that, which nobody does these days. So it's a bit of a shame, but that's how it works. So the good news in all this is that browsers optimize heavily page load time. So even if you don't do everything perfectly, they will compensate a lot. For instance, they parse HTML incrementally as they get it from the network. They don't wait until they have it completely. If they are blocked because they have to download and execute a script, they will try to paint off screen everything they have up to this point, provided they have downloaded some CSS, and so it doesn't look too crappy. If they're waiting for web fonts, they will do a first render with a default font after 3 seconds or half a second on Chrome and Firefox. Well, 3 seconds on Chrome and Firefox, I think half a second on Internet Explorer, and never on Safari. So if you're on Safari or iOS, you have to click the read mode button so you can just read the text. And perhaps the most interesting optimization is a preload scanner. That's an optimization where the browser is going to look for script tags and style tags in the HTML and start fetching them even before DOM construction reaches this point. So that's getting into the black magic territory. So yeah, to sum up, this is the reason why the proper order of optimization is first HTML, then CSS to unblock the first paint, even if you're waiting for JavaScript. Also unblock JavaScript execution. And then to avoid synchronous JavaScript, or failing that, put it at the bottom to avoid blocking DOM construction because there's nothing left to block if the script is at the bottom. However, it will still delay DOM content loaded, which is the point where you can start animating your page. So it's not ideal. So I waved my hands repeatedly about this sync JavaScript thing, and I told you not to put script inline, but what's the alternative? Well, there's a better way, which is called async script. So I guess most of you are familiar with this wonderful piece of software, which is the Google Analytics tracking code. I deobfuscated it, which will make it a bit easier to discuss. And here we have a very interesting pattern. They are creating a GA function, which creates an attribute on itself, which is a queue, which is instantiated as an empty array. And whenever GA is called, it will just take the argument it was called with and push them into the queue. And then later, the analytics.js script will kick in and will loop through this queue and handle this function call. So this is called the async function queuing pattern, and I think it's going to be a pattern we're going to use more and more to optimize the front end. The second interesting thing here is that they're creating a script element and inserting it into the DOM. And the reason for doing that is that this pattern is called a script injected script, and it doesn't block DOM construction. So executing this piece of JavaScript is going to block DOM construction. However, downloaded and executing this one, which is much larger, will not block. So that's smart. They have good engineers. It will still block a little bit, and there's a better way, which is the alternative Java tracking snippet, which is shown on the same page, but surprisingly below, while it's a better version. And it looks like this, and once again, it's slightly better if you deobfuscate it. We have exactly the same async function queuing pattern, and here we have script async. This is magic. So what does script async do? Two things. First, it doesn't block DOM construction. The browser will download the script, execute it when it's ready, but will continue parsing the DOM in the meantime. The second thing it does is it doesn't block on CSS readiness. So the script will execute when it's fetched, regardless of what the browser is doing with CSS. And this is a good thing because most JavaScript doesn't care, well, it's not going to read your CSS or write in the document. So these arbitrary restrictions can be ignored with the async keyword. If you are targeting old browsers, so typically IE 9 and earlier, Android 2.3 and earlier, you have to write script async defer, add a defer, which does almost the same thing and should work. So I'm taking bets, and I may lose, but I'm taking bets that the future best practice for performance in web pages is going to look more like this. If you need to expose an API to other scripts, likely you will expose it with some async function queuing, like we just saw for Google Analytics. Then you will put your styles, because, there's the most critical thing for showing something to the users that makes sense. So you want to start fetching them as soon as possible. Then if you have some JavaScript that's critical for rendering your page, because your page doesn't show anything without JavaScript, put it there so you can start downloading it immediately after CSS. And finally, this is optional, but if you want to do some, to pre-render a little bit of your page before you have even downloaded some CSS, you can inline some of your styles just enough to render your header and perhaps the beginning of the page. So this is some fairly advanced optimization. It's not very convenient to set up, but well, it exists. And finally, keep putting at the bottom everything else as script async. And pray for HTTP 2, because when we have HTTP 2, we can stop minifying, we can stop concatenating, we can stop inlining, we can stop striking, we can stop all this crap. But that's in 5 years. Okay, credits to this guy who works at the Make the Web Fast team at Google and who knows a bunch about performance, and you can read everything he wrote if you want to know more. That's it for front end. Let's talk about back end for now. Let's talk about backend now. I think it was really important to talk about front-end because first you're all more familiar with backend, and as you can see, it's not that scary. If you take things with method, you can understand what goes on. I would like to describe, similarly to what I did for the browser side, I would like to describe what happens on the server side. Fortunately, it's a bit simpler, especially since we got the new model for middleware that's landing in 1.10. So now it looks like this, leaving aside channels for a minute. So we're in traditional mode for serving requests. At the very beginning, the request started signal is fired, and the request object is built from the WSGI environment. So this is the request object you will receive in your views. Then we enter the middleware. So now middleware is a callable that receives a getResponse function, and it can call getResponse to call all the middleware after itself and the view. And so it doesn't know really what's after itself. So each middleware can run code before calling getResponse and after calling getResponse. So this is the part that's before getResponse, and you can imagine that you can have multiple middleware in a row here. Then you have really the core processing of your view that will involve URL dispatching, executing your view, so that's where your code lives most of the time. And if your view renders a template response, separately from that view, the template response will be rendered. So that's the point where the context is interpolated into the template. And so this can take some time. And so if you just benchmark the runtime of your view, you may be surprised because a lot of time may be spent there, actually. Furthermore, in between these steps, if you're implementing a class-based middleware and you have a process view, a process template response, or a process exception method, these methods may be called. I think they're going to fall out of fashion, except in cases where they're really necessary, because the new middleware model supports them, but it's easier to just put the code here or there after calling getResponse. And after going through the response middleware, so which are the same as the request middleware, but in reverse order after calling getResponse, you end up returning a response object, which Django passes back to the WSGI server by calling the start response function and returning an iterable, basically. And this can still take a bunch of time because the WSGI server will iterate on the object you returned, send that data to the client, and once that's done, it will call the close method of the response class, which will fetch the request finish signal, and it's at that point that the view has really finished executing. So the total runtime goes from request started to request finished. The easiest way to instrument is to hook to the signals, but you can also instrument at various points in the middle to understand what goes on. Specifically, you should be careful about middleware because these execute at every request, and if you have a middleware that does 2 SQL queries, it's going to do 2 SQL queries for every single request to your website. So usually middleware are small individually, but since they're executed a lot, this can add up. I started talking about SQL queries because, as you all know, when something's slow in Django, usually the best thing to do is to look at SQL queries. And it may not be the database that's slow, it may be the ORM that's slow, actually. We're going to see this. So I made a quick test setup with a table generated by pgbench, which is a tool for benchmarking PostgreSQL. I created about 300,000 transactions, 330,000. And the structure it generates looks like this. So I have, it's a schema for a bank, but it doesn't make a lot of sense. I have a branch which has accounts, which has tellers who serve transactions, and the transaction tied to all the other objects. I deployed this to Heroku, so you can go take a look at the thing live if you want. It's running on a Hobby Dino and a Hobby Basic Postgres at Heroku, which is a representative setup of many small sites, I think. And I mean, perhaps these sites are those who can benefit most from the optimization I'm going to show. So I think it's a good test setup. I didn't generate the data over there because it would have taken about 5 days. So I just copied it from a machine to Heroku. So the first thing I'd like to talk about is selecting and prefetching related instances. So let's start with select related. I guess most of you have at least heard about it, but let's recap quickly. Here I am in an admin views that shows my transactions, and for each transaction I'm showing the teller, the branch, and the account. And of course, that's making 300 SQL queries, because for each row it makes a query to get the teller, a query to get the branch, a query to get the account, and so I have 3 times 100 queries. So that's bad. And I can override the getQuerySet method in the admin class just to select related tellers, branches, and accounts. Or even better, I can use listSelectRelated, which is a shortcut to do the same thing, and suddenly it's so much better. I have only 4 database queries, and the last one isn't even that expensive. It takes like 4 milliseconds. So the thing is suddenly 20 times faster than it used to. So what does SelectRelated do? Basically, it just create a join to related tables. This uses exactly the same joins as Django would use if you were filtering on related objects. And it can follow foreign keys forward. It can follow one-to-one field forward because they're pretty much the same as foreign keys. And it can also follow one-to-one field backwards because just Django knows how to make these joins. You can call select related without any arguments. And in this case, it will follow all non-nullable foreign keys and one-to-one fields recursively. So it can go quite far. For this reason, it's not a very good idea because you could have accidental performance regressions if for any reason you had new foreign keys and suddenly Django starts prefetching them. So always specify explicitly the data you want. This behavior of fetching only non-nullable foreign keys doesn't make a lot of sense to me, to be honest. It's implemented like this because when the foreign key is not nullable, Django does an inner join in SQL, and when it's nullable, Django has to do a left outer join. And there were circumstances where the left outer join is much slower. I'm not sure these circumstances still exist these days, and there's a serious drawback to the current behavior is that the admin automatically adds a select related for foreign keys, but only if they're not nullable. So that's why I had the problem. The foreign keys in my example are nullable, so I had to add the select related explicitly. So all this sounds a bit messy, and I would love to take a look at the sprint to see if we can change the behavior because we consider the performance difference is no longer significant these days. Let's move on to its friend, prefetch related. So here's a variant of the same problem. Here for each, so this is a view of accounts this time, and for each account I want to show the list of transactions. So of course this is naively making 1 query per line to fetch a transaction. I have 100 and something queries which appear here duplicated 100 times. And I can use, this time, prefetch related by overriding the query set like this. I just ask Django to prefetch related transactions for each account I'm selecting. And once again, it's so much better. This time I have 5 queries. And you notice that it moved from 304 to 5. So actually, the prefetch rating is making 2 queries, which we are seeing here, the first one and the second one, which prefetches the related object. So how does prefetch related work? It's very different. This one does 2 queries. The first one without the related object, and the second one only to fetch the related objects. And then it does a join manually in Python. So it just adds, it just attaches the related objects to the primary object. So the related objects are prefetched with a big select something where ID in, and then a big list of IDs, which isn't a very efficient pattern for databases, and DBAs like complaining about this. Technically, it would be possible to reuse the condition used for filtering the original query with some sort of joins, and extract the related object like this. It's unclear that it would be faster in general. There's a ticket about it, which hasn't moved forward, probably because it wouldn't be much better, or perhaps worse, quite often. So this technique works for any kind of relationship, foreign key, one-to-one, many-to-many, forwards and backwards, because the 2 sides always share an ID somehow, and you can always figure from this column the set of IDs you need to look up in that column in one of the fields. It even works for generic foreign keys, but if you use generic foreign keys, I'm sorry. That's what I will say. There's something to be careful with when you're using prefetch related, is that any query set you have prefetched, you cannot filter or order or anything, because that would cause Django to make a new query to the database to fetch this modified query set, and that would entirely negate the point of prefetching in the first place. However, if you need to customize the query set that's being prefetched, you can do it with a prefetch object like this. So for instance, here I'm telling Django to prefetch the transaction set by using transaction order by -m time. And so Django will select the subset of this needed to attach related transactions to my original query set. So the signature of prefetch object looks like this. You tell it the lookup you want to follow, then the query set you want to use as a basis for prefetching, and then you can specify the attribute where you want to attach the prefetch query set on the original model. And this is very useful, because if you filter the query set you prefetch, and you attach it to the same attribute as if it hadn't been filtered, it's very confusing, because you have fewer objects than what you would expect. So attaching under a different name, it should be a mandatory practice whenever you filter the related query set. Ordering doesn't really have this problem, so it's less of an issue. Finally, one last thing I discovered while making this presentation, if you want to do prefetching on a set of objects that doesn't come from a query set, you can do it with prefetch-related objects. So you can pass it a list of model instances you have around for any reason, and it will do the same thing. So that's cool. So when should you use select-related or prefetch-related? First, if you want to prefetch many objects, you don't have a choice. Select-related doesn't work in that case. However, if you're in the something to one column, so that is forwards foreign key, forward one-to-one, or backwards one-to-one, you can use either. And the documentation says generally you'll want to use select-related. I think it's largely an aesthetic issue, at least, because select-related will do a join in the database instead of doing a join in the application. And as proper developers who understand the role of the database and the application, we feel bad about making joins in the application. However, the performance implications aren't obvious. the factors are the following. First, select related will fetch more data, because if the same related object need to be attached to several original objects, it will be fetched as many times. So you end up fetching some instances repeatedly and instantiating them repeatedly. However, prefetch related also has some drawbacks. First, it makes multiple database query. It makes one query per lookup and one query per level in the lookup. So if you're joining to multiple tables, it will do one query for each step in the join chain. And while it does this, it could run into transactional consistency issues. I think this is largely theoretical because I discovered the bug again while preparing this presentation and filed it, just saying it's possible this could happen. I'm interested if people have seen this in practice. At the end of the day, which one is the fastest will mostly depend on the latency to your database, and the latency will penalize prefetch related because it does multiple queries. So I did a quick benchmark so we can see how this pans out in practice. And for example, let's fetch all 300,000 transactions with the related accounts, and I have 100,000 accounts. This takes slightly above 10 seconds. Let's do this with prefetch related. It takes less time in the database, 1 second versus 1.32. However, it takes more time in total because reattaching all the objects in Python is slower. Now, if we're doing the same thing with tellers, there's only 10 tellers. So fetching them is basically free. And this time, prefetch related is slightly faster because it only creates 10 tellers and then attaches them to all the transactions. However, it's only very marginally faster. If the teller model was larger, perhaps the difference would be more significant. So yes, this is very application dependent. So now the $100 question is, if you're doing an API, all this stuff with the debug toolbar and everything is nice, but it doesn't help because you don't have the debug toolbar around for your AJAX query to your API. Fortunately, there's a solution. First solution is to reproduce the same query with the HTML UI of the Django REST framework. So you can take the URL used to fetch a JSON, just put it in the browser, and you'll get a nice HTML UI with the debug toolbar shown. What I recommend is to enable logging of database queries like this. You just have to set the log level of the DjangoDB backend logger to debug. And then when you see something like this in the console, you know you're in trouble. And when you see something like that, you know that the trouble is fixed. If you want a slightly more beautiful display with colors and sparkles and everything, you can use Django Dev Server. It's a project that overrides the runs for command and provides some nicer output. So that's it for select related and prefetch related, which are probably the most important and also slightly tricky optimizations. I'd like to take 5 minutes to take about a few other ORM optimizations and when it's right to use them. So for this example, I'll still use the same data set. And this time, I'll try to compute the total balance of transaction by tellers. This doesn't make any business sense with these models, but I think it's representative of something many applications do, basically taking data and grouping it and summing it. So a naive implementation is just going to iterate through all the transactions, and for each transaction, add the balance to the appropriate teller. So here I'm using a default dict to make the implementation a bit more compact, so every teller starts with a balance of 0 by default. Now, this is a bit wasteful because we're only using the teller ID and delta attributes, not the rest of the transaction object. And so we would like to fetch only these attributes, which we can do with .only. .only has a friend, which is .defer, which does the opposite. You specify the fields you don't want. Unfortunately, while this is about 3 times faster in the database because you fetch less data, it's slower overall simply because the overhead of managing only in Python doesn't make this optimization worth it in Python, in this case. So you can use only and defer when you need model instances, perhaps because you want to call some method on them. but you don't need all the data, the columns, and especially you don't need some columns that contain large data. If that's a use case you have in your application, most often the right answer is not to use only or differ, it's to move that data to a separate table that you can join when you need it. And so, for instance, when you write to this model, you don't necessarily rewrite to the other table, you only write the small part that is often accessed and modified. So since that didn't work, we can try the next tool in the toolbox, which is values list and values. So here I'm going to ask for transaction.values list of teller ID delta, and this will give me an iterable of tuples containing a value, a teller ID and a delta, and so I can just unpack the tuple like this while iterating on it and summing. And this is way better. The database is 4 times faster compared to the original version, and the total time is almost divided by 10. And this is a little known fact, is that instantiating Django model instances is super expensive. So here I'm trying to instantiate 300,000 transactions, and it takes about 20 microseconds per instance, which adds up when you have 100,000 of them. It's expensive notably because when you call model.init, that triggers the pre-init signal and the post-init signal, which aren't widely used, to say the least. So there's almost never a receiver for the signals, but still calling them as a little bit of overhead, and that's part of why model.init is slow. So there are huge gains to be made here when you just need the data. You don't need a model instance. You're just going to manage the data with functions that aren't methods in the model. And you have a large amount of data, and it hurts to say large when we're talking 10,000 rows, but that's Python, it's not that fast. At least CPython isn't that fast. And so a common use case for this is if you want to build a report where you're going to extract a ton of data to give it to someone else, you can have a huge improvement with values list of values. Finally, this one is almost my favorite. Django has some annotation and aggregation functions. And these are a bit difficult to use, but they're very powerful. So, for instance, here I can simply ask for the list of tellers, annotated with the sum of transactions for these tellers. It's about 6 times faster than the original version in the database, or 7 times faster. And it's like 100 times faster overall. Because once I get the result in Python, I just have to make a dict that contains 10 values, and that's it. So it may not be obvious to everyone that this was the right thing. At least it's not obvious to me at all. So I always print queryset.query to check the generated SQL and to see if it makes sense. And I'm pretty sure that this does the right thing now that I've seen the SQL. That's the only way I managed to write annotation and aggregation queries, and I've written a lot of them. So annotate and aggregate are fantastic when you can express the entire calculation in the database, or at least a large part of the calculation. And when you need to manipulate, once again, large amount of data, if you're just fetching 100 objects, it doesn't matter because it's going to be fast anyway. A very common use case for this is dashboards or KPIs, well, SIGs management we want to look at. There's a learning curve, but I think it's well worth it. And a last one, which is very rarely used, it's iterator. It has an entirely different purpose. This one is not about optimizing CPU usage or database queries. It's about optimizing RAM consumption. So what iterator does is it allows you to iterate on a query set, but the results are not cached. So if you iterate on the query set again, the results will be fetched again from the database and iterated on. So this avoids keeping the entire query set of model instances in RAM, and that's why it's more efficient. So there are 2 huge caveats to this. If you keep references to the instances, there will not be garbage collected, and so you will still fill up your RAM with all the model instances. and also they're all fetched at once from the database. So what you're saving is the extra cost of taking the data fetched from the database and turning it into a Django model instance. So let's see what this gives in practice. We'll use the trace malloc module, which is new in Python 3.4, and which for me is the first memory measurement system I managed to understand in Python. I used those one before, but they were complicated. And we can just do trace malloc.start, run what we want to measure, and then ask how much memory was used. And in this case, it used 160 megabytes, which is about 500 bytes per instance, which isn't totally bonkers. Makes sense. Now, if we slap an iterator on this, we are down to about 200 kilobytes, which is 3 orders of magnitude smaller, because the garbage collector kicked in regularly and collected instances while we were iterating. So it's really easy to benchmark memory use with this, and I think it can be useful. So that will be all for today. And if you have questions, let's go.
Thank you very much. Predictably, we have a bunch of questions. Oh, yeah, close enough. So talk was slightly in two parts. So I'll start off with some questions from the sort of front-end JavaScripty part. So can you do asynchronous CSS to sort of do a small initial piece of CSS for the basic styling and load the rest of it after the first paint?
So yes, you can do this. You cannot entirely control at what point the browser will trigger a paint because it will depend on what's cached, etc., etc. So the approach that's usually taken for this is to inline the CSS you really want first and put the rest of the CSS later down the page, which makes it a little bit de facto async. So this is really the inline small CSS in the head tag is the right approach to this, in my opinion.
With the content hashing name solution, is content hash as an e tag a good enough solution for many people?
That's a very good question. I have spent a lot of time trying to make e-tags work, and I could never convince myself that I did the right thing in all browsers with taking into account gzip and reverse proxies and Cloudflare and you name it. So I think e-tags were a good idea originally, but that didn't turn out to be very practical, and I would recommend against using it because it's more complicated than what works best.
So moving on to more ORM-related queries, which we've got a lot more of. Can you imagine a sort of future stricter version of the ORM that would error out if queries weren't prefetched directly? The example is it's very easy for, like for select-related style foreign key query for a template author or a front-end engineer to add something there, and suddenly you've got one of these k times n+1 problems that you didn't know you had.
Yeah, so this doesn't sound entirely trivial because it means you have to differentiate between a query set the developer created on purpose and a query set the developer didn't create on purpose. And code has a hard time reading the mind of the developer. So I can imagine ways where you would declare explicitly on a query set the list of relations you would allow the developer to follow on this, and it will error out if, for example, a template tried to access a relation that isn't allowed. Well, I think it would be doable. I think it would be quite annoying as well.
I would agree. Does the iterator method, does that cache and reuse model instances, or does it throw them away then garbage collect them?
So what iterator does is just it will yield instances into the code that calls the iterator, and the expectation is that this code will do something with them and then just lose references to them so they get garbage collected. And at least Django is very careful not to keep references to them, So it's entirely a problem of user code.
And when iterator's working, it just works within Django, or does it use the database itself to do the iteration?
Oh, yeah, right. No, as I said, the entire query set will be fetched from the database at once. There's no support for things such as server-side cursors. It would probably be possible to implement that. I think we'd accept a patch for that, but it hasn't been done yet.
You mentioned about printing out the query because you don't trust your annotation and aggregation queries. These are less mental than they used to be, I hope. Now we have expressions in the ORM. Can you think of any further things that we could do to make it easier to understand and to ascertain whether the right thing is happening?
Well, the thing is, you will usually write a combination of values and annotate. If memory serves, aggregate can only return a single result from a query, which isn't the most useful thing. And if we just go back to the slide, for instance, I find that the values list that annotate something isn't entirely obvious. My first instinct would be to fetch the teller ID and the delta and then do something with them. So as far as I'm concerned, I always manage to write what I want to write, but it takes a lot of trial and error to figure the right order of invocation. So perhaps we can improve documentation about that by describing a process for writing these queries. But, well, I'm not able to describe it right now.
It gets even more confusing when you're then doing a values list for performance afterwards. So you're doing a values list in two different places in the query to do different things.
Yeah, and then you can change this for as long as you want.
Yeah.
So I know I've written queries like this that span like 12 tables, and that they took a whole page of code and they did the right thing and it worked, and I needed this because they reuse query sets that I defined somewhere else. So you can take this extremely far and it works surprisingly well. It's just, well, as I said, there's a learning curve.
Could you imagine a hypothetical GraphQL API that would sort of implicitly insert prefetch relateds or select relateds or onlys or defers or whatever as necessary based on the query that we're actually passing into it?
Well, this is the more general question of how you implement a GraphQL API on top of an SQL database. I'm not sufficiently familiar with GraphQL besides the general concepts to see exactly how you do it in Django, but I suppose Django isn't that bad of a starting point to do it, since you have all the pieces in the toolbox. It's just a matter of parsing GraphQL and putting them together, so it fits.
So
if someone has a few years to write this.
I've actually written some of that myself. It's not open source yet, but I'd like to make it so. In JavaScript land, or in GraphQL JS land, one of the approaches that they've come up with to solve this problem is a thing called data loader, where it sort of does like a promise-based prefetch related. So you just kind of access data and it returns promises all the time, and then at some point it returns it. My feeling is that doing that in Django would be extremely difficult and require much better asynchronous support in an ORM.
Well, one way to look at it is to say that this is a lot like the lazy fetching of query set results. So in that sense, it's taken us a decade to have all these optimizations implemented in Django, and we're rather ahead of the curve when it comes to this sort of thing versus the more immature JavaScript thing. So now I think the GraphQL is going to catch up and we'll have a good way to do GraphQL on top of an SQL database. I don't think it's completely stabilized yet.
Do you have any more memory debugging tips like that? Trace malloc, I think was the right thing.
Well, yes, trace malloc.
Like that we can use?
I wanted to make an example with hippie and guppy, which are things I used before, but I realized that one of them hadn't been ported to Python 3, so I couldn't show an example. And generally, they were extremely painful. The only situation where I really needed them was to debug a memory leak in a C extension. Which is not the sort of thing you do every day, at least as a Django developer. You can probably debug it with trace malloc, and it's probably less painful. Trace malloc can show all the objects that have been allocated and display statistics, so you can see what's most allocated, etc. So it's much more powerful than what I showed. It was just a teaser.
dead on time. Thank you very much, Aymeric.
Thank you.
So that concludes our talks for today. I hope everyone's enjoyed them. I certainly have. We will see you all tomorrow. A couple of quick reminders before we go. Firstly, there's the dinners being arranged for Saturday. If you go to underthehood.com/dinners, I can see a lot of them are starting to fill up now. If we get all of them full, feel free to add your own ideas, go and organize one yourself, and other people will come along. It's a great opportunity to meet people. I've also seen a bunch of discussion happening in the dinners channel on Slack for tonight. If anybody wants to meet up with some new Django friends and go out for dinner, it's a great idea to do so. Yes, there's a pinned post in Random, which is a map of all the places that Jacob could get a recommendation of somewhere to eat. If you have anything else, I'm sure he will happily update it, but that gives you a good idea of where to go out in Amsterdam. Thank you very much, everybody. We will see you bright and early tomorrow morning.